Hi, everyone. So we're going to get started shortly. I just want to make sure I do have all the access, and I'm also going to share the slides and the notebook for today's class for you. So let me make sure I have everything set, and then we will get started. All right. So let me also share the link. So you should be able to find the resources under the same Google Drive directory as last time, but just to make sure, I'm also gonna share the links here. So here's the link to slides. Oh, sorry. So I need to send it to everyone, not just our operations. Link to slides. It will be this one, and link to our notebook. All right. So I also shared the links on the chat. So hopefully there's no issue. Okay. So let's see if I have everything else. Okay, so cool. I think we have everything set. I see there is a question that I tried practice test for week 1. My answers passed, says good to go, but it doesn't say said completed even after I tried so many times. So indicate 0 attempts made. So for any questions regarding the practice set and any issues with the up level, if you can reach out to operations, because I'm not sure about the answers really. If there are any issues, if you submit your answer, you don't see any changes, please reach out to operations, and because they are the team who designed these interfaces for up level, and they can help you better. So okay. So looks like that second link doesn't work. Not sure why, but for me, it's actually working. Okay, so let me share the link to the notebook again. All right, so try again. So I shared it once again. Okay, cool. So it seems like the link works. And then there's another comment to the previous question. Try running all tests, and after that, it will be considered as a complete attempt. Thank you, Kunal, for the answer. Okay, so let's go ahead and get started. Let me. Okay, so I believe my screen is also shared. Awesome. Okay, cool. Hi, everyone. Welcome to the second week of Python Fundamentals. My name is Siavash. I'll be the instructor for this class. So this would be the second part of the Python Fundamentals series. We started from some basics, and then we continued with learning some data structures in Python. We learned about lists and strings. So in this class, we're going to actually continue that and then learn some more tools and techniques in Python. So before we go over the agenda for today's class, I just wanted to remind you of some announcements to optimize your experience, actually. So make sure you interact with your instructors. The format of the class is pretty similar to the previous week. You can put your questions in the Q&A. We shall have a TA for this class, but if your questions are not answered, I make sure after each topic I stop and try to answer those questions. If I don't know the answer to any questions, then I make sure that the answers are on the notebook, which will be shared after the class, which was the case last week too. And then if you need more clarifications after each topic, I let folks raise their hands and ask their questions. We will have time for maybe a couple questions after each topic, but then at the end of the class, I'll make sure that I stay, and if there are more questions, I'll be happy to take them. And the reason is the class is actually, this is a 4-hour class, but based on the Q&A during the class and how much time is left for each topic, it usually takes around 4.5 hours, 4 to 5 hours. So I understand that some learners have to drop. They have, they need to drop at the 4-hour mark. So this class is recorded. It's part of the resources available to you after the class. So if you need to drop for any reason, feel free and then catch up with the recording. Then we will have another session on Thursday for assignment review. So you should be now familiar with how actually it works. We're going to have some review multiple choice problems and some coding questions. And so for those of you who actually were able to attend that class, we usually try to test our understanding of what we learn in the class based on all the tools and functions in Python, because that's the focus of the class, not the efficiency and optimization of the code. But for those problems which made sense and we had the right knowledge, we would go over some more fundamental solutions to those problems, which could actually be more optimized as well. So that's again the case this week for this assignment review. So try to give those questions a shot and come prepared to the class so that it will be even more useful. So here's the agenda for this week. We are going to have a very quick review on lists and strings, just to make sure we have all the important data structures in one place. We're not going to have a coding review, just going over the slides we covered last week, where we ended. This is going to be a very quick review on those two topics, and then we're going to continue that with tuples, sets for the first part of the class. And then after the break, we're going to continue with dictionaries or hash maps in Python, how to define them and how they work, and what are the differences between all these data types. And then we will continue with how to define a module in Python, how you can use built-in modules, or how you can define your own custom module. And then we're going to end the second part by functional programming and some functions which can be helpful in making your code shorter and more readable. We're going to learn about Lambda functions, and then we're going to learn about map, filter, and reduce functions in Python. And then at the end of the class, we're going to wrap up by reviewing the scope of variables in the code and define calling by value in a function or call by reference. And we're going to see a lot of examples in all of these sections. Again, for this class, we also have some lead code problems assigned to you. So again, usually in the class, we don't get enough time to go over the solutions, but this, you can think of this mainly as some, kind of assignments that, all right, now that we know these topics, these are the questions that you're able to think of some solution. Not the best solution or optimized solution, but some working solution. So if I realize that we have enough time, when we get to each of these questions, I can stop and give you a couple minutes to think about them, and I can show you the answer. But if not, then I will provide the solutions on the notebook, and I encourage you to work on these on your own after the class sometime, and then take a look at the solution and see where you got right or wrong. And if you have any questions, we can actually go over those in the assignment review session as well. Actually, we do have some problems similar to these under assignment review, but it would be great if you have actually, you get some practice before that. All right. So before we go to the first topic, I see there's a question that are the assignments graded? Do we get points? I don't believe so. I think it's just for your own exercise. Yeah, I don't think they are graded or it will be submitted anywhere. It's just for your own practice. So there is another question. The link is not working for me. If you mean the link to the notebook, I provided that again. So I provided two links. First, it was link to slides and link to notebook. But then, people were telling me that the second link is not working. I provided it again, and seems like it's working for some folks. Yeah, so then if you cannot access to those links, I'm not sure really where I can share them. So I've shared them on the up level on the link to this class from the instructor side. Learners should be able to see those things updated, those objects. And I see that there are comments that this is working for other folks. If it's not working for you, please reach out to the operations right now and let them know. Everyone should be able to get access to those links. Even without me sharing it in the class, you should be able to go to up level. On your profile, you should see a calendar, and then under the resources for this class, you should be able to click on it and see whatever I've uploaded there. Okay, so let me actually do this. I'm gonna delete the one which is not working, which I have no idea why. So I deleted the link I shared, which is not working, and then let me share the slides, which is not available right now here again. So now you should have a link to slides, and let me also share the notebook again. Here's the link to the notebook. I really hope that this works. If not, please reach out to the operations because I honestly don't know what else I can do for this. Okay, so hopefully you have access now. All right, so let's get back to the first topic here, which is a quick review over lists and strings. So we realized that from now on, we're looking into collection of items, right? So we have a sequence of items, which the container of those items are different and they have different properties. So I get a lot of questions on why do we need so many different object types like lists, strings, and later tuples, sets, and dictionaries. The answer is that each one of these have their own characteristics. And the main thing is the difference between their specialized methods defined. So as we move forward, I will let you know what are the main differences and why do we need both of these objects when we get to that comparison. But for now, we need to know the main thing, which is all of these are a collection of items, and there is sequence, which we can iterate, and we can get access to those elements, and we can actually use the methods built in Python for different purposes. So we already saw these two, and we realized there's so many similarities between the two. So let's take a quick look again. So we understand that lists are mutable. When we say mutable, we mean we can actually change them after we create them. And there are a collection of elements which are ordered. So we do have indexes defined for different elements of lists, and you can get access to those elements using their indexes. And because they're mutable, we can manipulate them, right? So it allows for dynamic storage of data that you can later add data if you need to. And because they're ordered, this data is added in a sequential manner. And the way you define them in Python is that you have square brackets with some elements in between, separated by commas, and each of these elements would be one element of the list. So if you want to get access to a list element, you can actually provide this index after the name inside the square brackets. And you know that by now, Python is both zero indexed and negative indexed language, which means the iteration starts from zero. And you can also start from the other side, where you will need actually to use negative indexes for that. So -1 means the last element. So there are some characteristics for Python lists. They're ordered, they maintain the order, they're mutable or changeable after you create them. They're heterogeneous, which means they can store various data types, not just one, or you can, for example, you can have both integers and strings at the same time. Then they're dynamic, which means we can expand or shrink or change them anytime to accommodate items. And they allow duplicates. So for example, you can have the same element on different indexes within a list. And that's all actually, you'll see why this is important. Later today, we're gonna introduce data structures which do not allow duplicates, and there's an intention behind that as well. Right, let me make sure. Okay, cool. Basic operations, accessing elements we saw, and then modifying elements have the same syntax, but then you have to assign a new value. If you want to get the length of the list, you can use the len function for concatenation. We have already seen that the plus sign means different things for different data types. For example, if you have integers or floats, this is an arithmetic sum between two integers or two floats. But if it's a string, then it becomes a concatenation. If it's a list, it's also concatenation, but in a different way, right? So it will concatenate two lists. So you have repetition. If you want to concatenate a given list with itself n number of times, then this is how you can write that. So this star symbol is also another operator, which means different for different use cases. Like in arithmetic language, you have this as multiplication. So later when we learn about NumPy, it means broadcasting. But in the case of strings, lists, tuples, for example, it means repetition. It's basically multiple concatenations. And then we also learned about slicing. So actually, there's a slide for that in a bit. But we saw some examples, very extensive compared to this example. But just to remind you, you can define a list in this way. You have your items. In this case, we have strings. Then you can actually get access to the index 0 to get its value. And then you can get the slice of your list from the begin. This is the starting index, which is inclusive, going all the way to the ending index, which is exclusive. And you can also define the step size, which is dropped here, and by default goes by a step size of 1, right? You can modify the elements using this syntax. For example, here we are modifying the first element, which supposed to be the apple, but now we are modifying it to grape. So it will permanently change that first element in our list. And this was the syntax for slicing. So by slicing, you actually get a new list, starting from some index to the end, and with the step size separated by columns. So if you don't provide these indexes, we have some default values. So for start, we have default value 0. For end, we have the length of the list if you don't provide it. And for the step size, we go with 1 if the step size is not provided. Okay, and we had this example in the class that we saw actually, a few different ways to slice our list if needed. All right. So the main point of difference between the data types that we're going to learn are the methods which are defined for them. So for Python list specifically, we have some methods which make it much easier for us to manipulate these objects. So we have append and extend to add more items to the list. We have insert to insert element, remove to remove, or pop and remove to remove elements. We have discussed all these in details, and we had examples in the previous class, so I'm not going to go through those details. But you can clear the elements, you can get the index or count of a given element on the list, and you can sort and reverse the elements in a list. And then there was copy, that you could get a copy for the list. And we had more. Actually, we saw more examples on the notebook. So this is not a comprehensive list, but maybe the most important ones. And then because lists are a sequence of items, you can iterate over the elements. Okay, and we saw how to iterate through a list. So this is the same for all other data types, which are a sequence and are ordered, right? So we also have iteration, for example, for strings, and we're going to see that. And then we had this list comprehension idea on how to actually define a list in one single shot. And this was the syntax for that. So we have the expression for the variable name in some iterable. So this iterable could be another list or any other iterable if some condition holds. So we have another example today on the first section in our notebook, which will review this list comprehension for you. And the use cases of list we actually covered as well. So before I continue with strings, I see the question if in concatenation there are different data types like integer and string, will it be an error or will it implicitly typecast happening? So there will be no error and there will be no typecasting. If you do concatenation for two lists and the lists have different data types, then it will concatenate those into one unified list, and it will have both data types, and there's no issue with that. Okay, so you can have both integers and strings in one place, so that there's no issue. So no error, no typecasting, it will just concatenate the elements. There's another question that list1 plus list2 is the same as extend. It's very similar, but list1 plus list2 gives you a new list. It will return a new list, but extend is an in-place operation. So if you use .extend, it will change your original list. It will not give you a new list. Actually, it will return none. Okay. Okay, so getting back to the slides, for Python string, so a string is also another sequence of items, sequence of characters. It's an immutable sequence of characters, which means you cannot change it after you create it. It will represent text data for and provides different methods to play with textual data, right? So if you want to, if you need any string manipulation, there are tons of different methods provided for Python strings for that. So if you want to create a new string, you can use single or double quotes, or you can use triple quotes. Basic operations, quite similar to lists. The only difference here is that you cannot modify a character in a string because it's immutable, and you cannot make any change to the immutable object. So now getting to different methods of strings, now you see that there's a big difference here. So you can, because you're dealing with text data, you can uppercase or lowercase your text data. We saw more examples on the notebook where we could capitalize or make the sentence into a title. You have many different methods to make those kind of changes to a given string. You can partition your string. You can replace a part of the substring. If you want to find a given substring, you can use find or index to do that. You could trim the white spaces from both sides. You could use the strip function to do that. If you wanted to do it from one side, you will do R strip or right strip or left strip. If you want to get a list of words from a sentence, you can use split. Split would split your string given a character. It will split based on that character. And you can check if the string starts with some given substring, or you can check if all the characters are numeric, they're all digits or not, and a lot more. So you could check, for example, if they're all alphabetic, alphanumeric, and yeah, so feel free to take a look at the notebook, and we had a lot more examples of these kind of functions in the class. And here's how you define a new string inside double quotes. And then you want to get access to the first character. That's perfectly fine, but you cannot make any changes to this character. If you want to actually change the first letter, you can actually get a new string. You cannot change the original string. You can use concatenation and other techniques to make that happen and get a new string with your desired changes, right? Or you can get the uppercase string using this dot upper method and other types of methods we saw on the list on the previous slide. Okay, so now that we know about these characteristics and these two data types, now we can move on to the next one, which are tuples. So before that, I see there is a question. List colon -1 reverses a list. Why is it not shown as list -1 colon -1? So the reason to that is if you want to reverse a list, you want to actually get all the elements and sort it backwards, right? So sort it in a reversed order. So if you put an index for start and end, then you may actually, I'm not sure what happens if you put a -1 in the as a starting index. I should try that out. But my guess is if you try to manipulate those two indexes, then you may not get all the elements, and yeah, that could actually defeats the purpose of getting a reverse of all elements. But putting -1 in as the starting index, now I'm thinking that may actually work because you're still going to start from the end towards the 0 index, but I need to actually try that out. So But the colon negative 1 that we saw in the class is a very classic example of reversing in Python. So that's kind of a known syntax, basically. And there's another question that, can I give some examples on list comprehensions? So we had a couple examples on list comprehension in the previous class because it's a topic for that class. So I would encourage you to take a look at the notebook from the previous class. But in today's class, in a bit, in this first section, I'm gonna actually show you a couple examples of that. Okay, so let's get there on the notebook, and then we have an example. But if it's not clear enough, then I would encourage you to go back to the notebook from previous week. Any other questions before I move on? So the question is the upper function converting in place? So none of the functions we learned for strings are in place because you cannot make any changes to a string because it's immutable. All of these functions are going to give you a new string. Okay, so they all return a value. All right, so now let's get to the next topic, which is tuples. So from this point on, you will see a lot of similarities, and you'll see many things that actually could definitely be the case for the other data types too. But intentionally, there are some nuances and some differences here and there, which makes that particular data structure very special, right? And something that you want to consider to use for a particular use case. So in the case of tuples, I would say it is very close in definition to lists because they're ordered, they are heterogeneous, and pretty much everything that you see from a tuple looks similar to a list, especially the way they're defined. Is the only difference is that you use square brackets for lists and parentheses for tuples. So almost everything the same. The only main difference is that tuples are immutable versus lists, which are mutable. So after you create a list, you can change it. You can add values or remove values, or you can insert values, or it will accommodate if you append or extend. It will accommodate elements for you on the in the in place. But tuples, there's no way you can make any changes because they're immutable, they're fixed, static, and this makes them hashable. So we are gonna learn more about that in a bit. But so that is the main difference between tuples and lists. Okay. So we're gonna talk about that more. But first, let's get some familiarity with tuples. Basic operations are pretty much the same as before. If you want to get access to elements, write the name of the tuple and then the index. You can do slicing, you can do concatenation to get a new tuple, or you can do repetition, but you cannot modify elements, right? So similar to strings, you cannot modify the elements in a tuple. So on the assignment review session, we learned about swapping the values of variables. And at that point, I mentioned that what's happening here under the hood is called tuple unpacking, but we never had any topics on that. So now we're gonna see what do we mean by tuple unpacking. So tuple unpacking is basically what the name suggests, right? So it's unpacking a given tuple into different variables. So we basically divide the values inside a tuple to some variable names, right? So what it does is it allows to assign elements of a tuple to multiple variables in one single statement, and it improves readability and the length of the code. So there's no need for index-based access to those tuples. So let's see a few examples to see how it can help. So the first one is if you want to return values from a function, right? So let's say you have a function, you have some operations. In this case, we are removing those operations because we don't need that. And then at the end, you need to return multiple values, right? So if you can actually return those values as a tuple, and then when you call that function, because the returned value is multiple values in a tuple, you can assign them directly to these three variables with this syntax, right? You just write the variable names separated with commas, and then this assignment would automatically assign these three values one by one to these three variable names. Okay, so this is one example of tuple unpacking. Usually when you define a function and you want to return multiple values, you return them as a tuple. Unless you explicitly need to return it in a different form, for example, a list. But usually from at least what I've seen, people return the values like this, or they will skip these parentheses. And if you actually don't put parentheses around multiple items separated by commas, by default, it will be interpreted as a tuple. Okay, so that's the first example. So the second one is swapping values without a need for a temporary variable. So here, let's say I am defining a and b to be 5 and 10, and then I want to swap the values. I can use this syntax: a and b equals b and a, right? So what's happening in these two lines, there are two tuple unpackings happen in each line. So in the first line, on the right side, I'm creating a tuple, 5 and 10, and I'm not putting the parentheses. I'm skipping the parentheses, which by default means I have a tuple here. Then I'm unpacking the values of those tuples into these two variables. So 5 goes to A, 10 goes to B. So this is, from this point on, it's a value assignment, right? So the left side is not a tuple, the right side is. And the values of this tuple are assigned one by one to these variable names on the left. Now, on the second line, I'm creating another tuple, B and A. I'm skipping the parentheses again. And B goes to A goes to B. So I have two values on the right, which are now 10 and 5. So 10 goes to A, 5 goes to B. So this is what's happening on the second line. Okay. And the third example is for more efficient iteration. So let's say I have this data set, which is a list of tuples. And each tuple has two elements. Then if I want to iterate through this list and I get access to both the ID and the name at the same time, I can use tuple unpacking in this for loop to get both of those at the same time. So this is also similar to what we do with enumerate, if you remember. But in this case, you can directly get access if you unpack this tuple into these two variables. So I have 1 and Alice in this data. When I'm looping through that, I get to each of these tuples one by one in that iteration. And then in the first iteration, ID gets the value of 1, name gets the value of Alice. And then I do whatever logic I have here. And then I go to the next iteration. Then 2 would go to ID, Bob would go to name. So each time in this iteration, I'm unpacking this tuple into these two variable names. Okay. Okay, so before we go to the code, the last slide we have here is to compare tuples and lists and some common use cases for tuples. So first of all, tuples are immutable. I think the main difference here is that tuples are immutable, lists are mutable. So that's the main difference comes from. So tuples are immutable, which means that they cannot be changed. And lists are mutable, which means that you can actually change them and add or remove elements after you create them. So now the other two differences are actually an implication of the fact of their immutability of tuples. So because they're immutable, they have a fixed size because you cannot change them, and they occupy less memory compared to lists. Okay, so because of the design and the way they're defined and cannot be changed, there's a fixed storage in the memory assigned to tuples, which makes them more efficient. And we will see an example of that on the notebook. But the other implication of tuples being immutable is that they are hashable. So they're allowed for keys in sets and dictionaries, but you cannot use lists for that. So the keys for dictionaries and sets, as we're going to see later today, should only be a hashable object, and only immutable objects can be hashed, right? So hashing is basically this mechanism of mapping some immutable key to some encoding so that you can actually get access faster, right? But so that the way it works is out of the scope, but what we should know is that only immutable objects are hashable. So basically that's what we need to know, and tuples are one of them. But you cannot hash lists because they're immutable. Okay, and then some common use cases when you think about data storage. So whether it's for security, for data integrity, whatever it is, you can actually store your data in a static way, right? So lists will give you a dynamic data set which you can change, and that's great if you need to change them. But if you need to keep them fixed, then you will store them in a tuple, because after you create them, no one can change it. And then if you want to return multiple values from a function, it's more efficient to do so with a tuple. And then you can use tuple unpacking to get those values. And then, we also saw another example of swapping elements. So this swapping values is not just for two values. You can actually have multiple values and kind of get a permutation of swapping their values. And this is a nice way to do this in one single line without using any temporary variables. All right, so now we're going to go to our code. So we're going to now see some examples of tuples. So first of all, let's see how to define a tuple. So we're defining a tuple here on line 2. So it's very similar to a list, but now we have these parentheses, right? So it's heterogeneous, meaning that we can have both strings, integers, and even other types in a tuple. So here's how the tuple looks like. And we also mentioned that the parentheses are optional. So if I don't put any parentheses on this, enclosing these data points, it still gives me a tuple. Okay. So we mentioned that tuples are immutable. So by that we mean we cannot add or remove elements, or you cannot modify elements. So here let's try to modify, let's say for this tuple, let's say we're gonna change the city, right? So we're gonna modify the last element. So if you try to do that, then you'll get this type error saying that this tuple object does not support item assignment. Okay, so you cannot make any changes to a tuple after it's created. But this is not the case for a list. So remember that if you had a list, you could modify the elements, and that's how we can do it here, right? So you won't get any errors of such. All right, so actually I have an example here I wanted to show you, which kind of also is a review on list comprehension as well. So I have a tuple here, and this is a tuple of lists, right? Sorry. And then here, let's say I want to get all the names in one place, right? So let's say I have a tuple of lists, and each of these lists are giving me the identity of a user, their name, their age, and the city they live in. And I want to actually get a list of all the names from this tuple, and I want to get a list of all the ages, and I want to get the list of all the cities that people are joining, for example, the class or something like that. So I want to give you a few seconds just to look at this syntax and try to understand what's happening here, and then I'm gonna go over that one by one. So let's look at this for a few seconds, try to see if it makes sense, how I'm using list comprehension, and then I'm gonna go over that. Okay, so now let me go over this. So the goal here is to get, for example, all the names of these lists. So from each list, I'm gonna get the first item, right? So the name here is the first item. So for this case, which is simple, we can do that. If the order of these things will change, then we will have a problem. Then we need to think about some other smart solution. But for now, let's assume that for all these lists, the first element is name, the second one is age, and the last element is a city. So I'm gonna iterate through this tuple. So I'm gonna think about this tuple in this way to make it more organized in my head. So this is my list. It has 2 items. It could have even more. I'm gonna go through each of these items in the list. Sorry, each of the items in the tuple, which is a list. Each item is a list. And then for that specific list, I'm gonna get the first item. Okay, so now let's see. Actually, let's see how we can write that without the list comprehension. So let's say names is an empty list, right? And I'm gonna write a for loop which says, for x in new tuple, right? So this is how I'm gonna iterate through this new tuple for x in new tuple, and each time this x is either of these items, right? I could also say for current list, right? And then each time I see a list, I'm gonna append the information I want. For example, in this case, I need the first element for the name. I will append the first element of that list to names, okay? And then after this for loop is finished, then I will get all the names of this list. This is exactly what's happening on this line. Okay, so I have a list defined with these square brackets. I'm gonna look at the first element of each element I see in the new tuple. Okay, so each time I see a list, I'm gonna get its first element. So this is what's happening here. Or you can get the second element, right? So switching this 0 to 1 will now give you the second element, which gives you the ages. And you can get the last elements, right? So which gives you the cities. So this is what's happening here. So if I print this, you'll see that I have a list of names, list of ages, list of cities. All right, hopefully that list comprehension thing makes sense now. But if not, feel free to take a look at the notebook from previous week. You can also do this in one single shot. Just take a look at this later and see why. But you can actually write a tuple comprehension in this case, right? So we also have tuple comprehension, like list comprehension, and you have a list comprehension as your expression, right? So this will give you all name, ages, and cities in one single shot. You're using two comprehensions here and an tuple unpacking on top of that to get these things. So I let you spend more time on this because it's not obvious when you just see it, but take a look at this more and see what's happening here. Then it's actually, we mentioned that tuples are immutable, but it doesn't mean that you cannot create new tuples that you need, or you cannot overwrite tuples. You can do both. So let's say I have this tuple here, and I actually want to change this tuple with a kind of new set of values, but I can't do that in place. What I can do is overwrite my tuple. You can definitely overwrite it, but then you're going to lose your original tuple, right? So you have two options here. So one, you can overwrite your original tuple by actually concatenating it with some other value, and then assign that new tuple to your original tuple. So you're going to lose your original tuple, but now you have the tuple of your choice, right? So if I print this, you'll see that now my tuple has a different value. But what's happening here is I didn't change the tuple. I concatenated the tuple with another tuple. So this is a tuple with only one element. And I overwrite my original tuple here. Okay, so let me actually put these two together. Now, what you could do, if you don't want to lose your original tuple, what you could do is you could actually do this concatenation, get a new tuple, and assign that to a new tuple, right? So in this case, you will not lose your original tuple. So if I run this one, I'll get the same thing, but now I have assigned this to a new tuple. Okay. So tuple unpacking, we have already seen that. Another example here is, let's say I create this tuple, I name it person, person ID or person. And then here I'm unpacking the values from person into 3 different variables, okay? So instead of getting these variables using person 0 or person 1, person 2, I'm just unpacking them into independent variables, and now I can use these variable names instead of indexes. Okay. All right, so one thing I didn't mention here. So here, we actually have a new syntax. We haven't seen this before. So I have these 2 parentheses, and inside that, I have only one element and a comma. But we usually have this comma when we want to separate values, right? So what's happening here? So the reason I'm using this comma is to actually define a tuple with one element. Okay, so if you have only one element in your tuple, you cannot define it like this. You definitely need to have this comma. The reason is an element or an integer enclosed by parentheses is basically interpreted as just a simple integer, because these parentheses are now kind of reserved for arithmetic operations, right? So if you have, for example, +1 here, what happens here is that you'll get a 4 inside parentheses, and then the parentheses will go away. right? So these parentheses here is for prioritization of your arithmetic operations. But if you actually want to change it to a tuple syntax, you need to have this comma to show that I'm defining a tuple with one single value. Okay, so here I have some examples. This is not a tuple. There's no comma. So if I get the type, it will give me an integer. But this one is a tuple. And if I print the type, it will give me a tuple. The same thing, not just for integers, but also for characters and strings. If you have only one element, you need this comma to define a tuple. So the next thing is iteration through tuples. How can we iterate given a tuple? We have seen that again. So let's say we have this tuple. You want to iterate through the values. You can write for item in tuple 1. You can print the items. You can end them in any way. So let's actually try this way. You can actually iterate through the indexes using the range of the length of the tuple. And you can use enumerate function to get both the index and the value at the same time. Okay. So pretty much similar to strings and lists. For checking the existence of an item in a tuple, you can use the in or not in operation, which you learned for lists as well. So here we were going to see if, for example, New York is an element of tuple 1, which is the case. It should give us a true. Chicago is not, so this should give us a false. And the third one says Boston not in tuple 1. And that is actually true because Boston is not there, and not in should give us a true, right? So this is the way we check the existence or we search the tuple. So next example is a few properties and functions for tuples. So again, we have the length function to get the number of elements. It gives us a 5 because we have 5 elements in this tuple. We have the count function to get the number of items. For example, we want to say how many p's are there in this tuple. It gives us a 2 because we have 2 characters of p. And then we can use the index function to get the index of the first occurrence of a given character. For example, here L is at 0, 1, 2, 3, index 3, right? So it's right here. And repetition is also defined for tuples. If you multiply, use this star or multiplication operator and a number, it will repeat your tuple 3 times. So the next thing is conversions. So we learned about typecasting last time. So now let's see how we can actually typecast between collection of items. So the first example is, let's say we have a list, and we are going to typecast it as a tuple, right? So here's what happens. So we get we have a list here. From there, we get to a tuple. Now let's say we want to do the other way. So we have a tuple here, and we want to typecast it as a list. You use the list keyword and the name of the tuple, which gives you the list form of that tuple. Now, if you have a string, because string is a sequence of characters, and you try to typecast it as a tuple, then it gives you a tuple of all those characters. So this is what you will see, right? And it makes sense, right? So you have a sequence, you want to get a tuple of that sequence, here's the tuple of that sequence. But how about the other way? So let's say you have a tuple of 3 characters ABC, and you try to get a string out of that, right? If you try to typecast it directly as a string using this str function in Python, this is what you get, right? So this is basically character by character typecast string that you get here. So this parentheses, opening parentheses here is actually a character, or these are all characters in your new string. Okay. So if you actually want to get a meaningful string from all these characters, which gives you something like this, then you need to use the join function we learned from the last class. So I want to join these characters with no space in between, and I want to get a string like this. So this is how we can do that. Okay. So I briefly mentioned memory usage. So I want to show you an example here. So let's say I have this list and this tuple. So both of them have the same number of elements, and actually this exactly same elements, same integers. Here I have a list. Here I have a tuple. So I'm going to use a module in Python named sys for system operations to see how much memory these two occupy. So this is showing me, I mean, this is out of the scope, but just want to show you how to get the size of items in your code. So this is showing us that even for this small number of elements in this example, we are getting a higher value, higher number of bytes for a list, even when we have the same number of values. So it will definitely get this gap will get larger and larger when you go to larger data sets. But because of its immutable nature, a tuple comes as a static data set, which allocates fixed, kind of fixed storage on the memory. So that's why it's really more efficient to define a tuple in those cases. Okay, so our last example is getting output from a function. So let's say this is another example for tuple unpacking. So let's say I define a function here, as you remember from the previous class. So I have the function name. These are the parameters or the arguments passed to the function. And then I get a quotient and remainder through these operations. And these are the two values I want to return. Here's how I return them. Okay, so I could actually put parentheses around them to make sure this is a tuple, but even if I skip that, by default, I'm returning a tuple with two values. So let's say I'm dividing 10 by 3 to get the quotient of 3 and a remainder of 1. So I do this dividing right here, and I'm going to unpack the values into these two variables, and I can print them out. Oops, sorry, I need to first run this one. Then I can print them out one by one here. Or I could do something different. I could actually divide them and get the value as this result, and I print result at index 0 and result at index 1. Okay, so this is the other way I could get access to those values, but I could get those as independent variables in one line, right? So actually I can go ahead and assign this like result 0 and result 1, but and then use these variables. But here I'm getting those in one single shot, and that's what you usually see in practice out there in actually real codes. So this is called tuple unpacking. Okay. All right, so we are done with this part. Before I move on to sets, I want to make sure that questions are addressed. I realized there were many questions on Q&A. I think they're mostly addressed, but let me go over them very quickly. So let's first see what's the time. Okay. So I see there's a question that due to connection issue, I logged in with a new device. Can I get the links shared? I think I already shared them a couple times. If you don't access the chat history, let me actually do that again. Yeah, this actually should be much easier to share these links. I don't know why we are going through so much for that. So here's the link to the slides. Here's the link to the notebook. It should also be available on your up level, but hopefully these links work. Is there any difference between this side with type hinting versus will both return tuple, person will return individuals? So I think the question here is what happens if I put int here? And the answer is nothing really. So it's not going to give you an error. It's just a hint to the reader of your code. So it's a very bad practice if you put some typing here for the output and then your output is different, right? So here your output should be basically a tuple of float and float, something like that, right? And then this tuple has to come from collections. So I let you look up for this one, but I think from collections you will import tuple, something like that. But yeah, it's if you're not sure about that, I would say you can skip type hinting, but usually when you write it, you're sure how your code is working. So it's not a good practice to actually put a wrong hint there. And the next question is, in upleveling the schedule week 2 link to Google Drive, is there for all 4 lines or 4 files? Yeah, that should be correct. So for week 2, the links in the Google Drive should give you the right links. So from the questions that were already addressed, so let me take a look and see if there are any ones that I haven't addressed. Okay. Yeah, I think I've mentioned all of those in the on the slides. Yeah, slicing also works the same as in lists. Um, um, I see there's a hand raised. Surab, you want to go ahead?
Yeah, you wanted to understand. So in strings,
Uh-huh.
that is another immutable data structure. But in that, we did not have an option in which you could reassign to the same string after concatenation, right? But over here, tuples, we could do that.
Yeah, you can do that for strings too. So let's say my string is random string, right? So let's say I want to add some in the beginning, some random string, right? So what I can do is I can say my string. So let's define this first and then write my string is some plus. Oh, actually, I need to write this on a code cell, my string, right? So now actually I concatenated this string with the previous one and I overwrite my original string, right? So if I print this, oh, actually I needed to put a space here. I'll get a new value for the same string, so same variable name, but here I have actually overwritten that value.
But then, so the memory changes, is it internally? What happened? How
Yeah.
does
So
this?
so internally now this is a different variable, right? So this is whenever you overwrite, you basically refresh, and then yeah,
Hmm.
the memory assignment is definitely different. Yeah, that's right.
Okay. Okay.
Yeah. So basically, you're getting the value from your original string, and now you're reassigning this thing to the same variable name. So that's basically overriding or refreshing the value of your
Okay. But actually, it's a new variable by
yes,
itself because the
yes,
memory is
that's right.
different. Okay.
Exactly, exactly. You're not changing your previous variable. You're basically renewing the value from the memory side. Yeah, that's right.
Okay. Got it. Thank you.
Yeah, thank you. All right. So I see there's another question, which actually let me actually give you example on that. So there was another question that um, so I we have, let's say A is 2, B is 3, and we get A, B is BA for swapping, right? And then if I print A and B, it's 3 and 2, right? So this is for swapping. Now, does it work with 3 variables? The answer is yes, if I have C4. If I have C here, then let's say I put a C here. Okay, now ABC has a value 342. So exactly with the right order we have here, we get the new values. So it's an tuple unpacking for 3 values. Okay, so B goes to A, now A becomes 3. So this is what we see here. C goes to B, we see 4 here, etc. Okay. All right, so let's get back to um, our slides. Okay, so we have 2 more to go. We have 1 more before the first break, and then we have another one, dictionaries, after the break. So let's go over sets now. Okay. All right, so sets are another data structure we're going to learn with some differences. Now, sets are unordered. So indexing and ordering is not the case for sets. It's just the storage, right? So it's the storage to keep some elements. And the elements that we keep in a set are considered as a key, right? So we call them a key because they have to be hashable. So we talk more about hashable when we get to dictionaries. But what basically means that all the elements in a set have to be immutable. Okay. Sets are heterogeneous. They can have different immutable values. For example, we can have integers, we can have strings or tuples in a set. And a set is a mutable collection of unique elements, so it does not allow duplicates. You cannot have 2 values with the same. You cannot have 2 objects with the same values, basically. So if you want to create sets, you use curly braces, or if you want to create a new set which is empty, you can use the set constructor. Some basic operations. First of all, indexing is not supported, right? Because there's no index. If you want to add elements to sets, you can use set.add, or you can use set.remove to remove elements. And you have a bunch of set operations, which we're going to see on the next slide. But basically, we have a new data structure which has, which is unordered, and it contains elements, but the elements have to be immutable. And there are some new functions that sets provide, which are actually the main reason we use them. So I actually want to kind of refer you to what we learned probably from calculus and how we did it for Venn diagrams. If you have seen these before, you can actually relate what we learn here to those diagrams. If not, then that's perfectly fine. We don't really need to know these things. But when I talk about, for example, if you look at down here on the left, the intersection of two sets, you can think of each of these circles as a set. And what goes into their intersection, which means the part which both of them contain at the same time, would be their intersection. Okay, so this is exactly what intersection of two sets in Python will give us. It will give us all the common elements between the two. And here's the syntax for that. You can use the AND operator, or you can use dot intersection. So we're going to see that as well. And then you can get the union of two sets, which means all the elements in both with this syntax using the bar. You can get a difference. For example, S1 minus S2 gives us the difference of set 1 minus set 2, which means all the elements in set 1, which does not exist in set 2. And the symmetric difference means the union of two sets minus their intersection. Okay. So these are some of the syntax we also see. We will see on the notebook as well. But if you have seen these diagrams, you know why they are useful, and this is exactly how we use it in Python sets. So some advantages of sets. So they're fast for membership testing. If you want to check that an item exists in one of these storing containers, probably sets is the fastest one, because sets and dictionaries basically work based on hashing, which, as I said, it's a mechanism for encoding the elements in a set to some mappings, which would actually make this checking the existence of a variable very fast, because now it's just a simple function map on each of those elements. So if you want to check an existence of an element in a list or a tuple, it has to go through a linear search through those objects. But for sets and dictionaries, it's the constant time operation, which means it's very fast. You can just check it with a function map. So the other advantage of sets is that they eliminate duplicates automatically. So there is no duplicate is allowed in a set. So if you need to remove the duplicates of a given list or tuple, you can basically typecast them as a set and then remove those elements and then bring them back to a set or a list or a tuple. And then sets also offer a set of unique built-in functions like intersection, union, difference, symmetric difference, and so on, which makes them kind of unique in that sense. And then common use cases comes from those advantages, like finding unique elements, removing duplicates, and performing those kind of operations like union, intersection, and difference. Okay. All right. Let's go back to the notebook. Now let's see some examples for sets. So to define a new set, you use curly braces like this, and then you put all the elements between the two. So now these elements have to be immutable, right? I cannot, for example, put a list here, right? So this will give me an error because all these elements inside the list has to be hashable. You can put a tuple, but not a list. Okay. Okay, so I'm getting this error because of a different reason. Let's not get into this. I will have it later, but let's define this set. Here's our set. We can use len to get the length of the set. And we can use max to get the maximum number in the set. But this max it has to be compatible, right? So this is why we got that error earlier. So if I put this back, if you have a tuple here, then there's an incompatible max operation happening, right? Because you cannot compare an integer with a tuple. Okay, so we know that sets remove duplicates. So let's say here I have these numbers, but when I define the set, so they're enclosed in braces, right? So when I define it, then I have a unique element of each, right? Now, sets are heterogeneous, which means that you can have, as long as these keys are immutable, you can have as many types as you need, like lists or tuples. And a set is not indexed. So basically, when you define a set, don't try to get access to those elements like what you had for the previous data types that we learned. If you try to do it, then you will get this type of error. So you have a type error saying set object is not subscriptable. Okay. So again, the elements of a set need to be hashable or immutable. So you cannot have a list in a set, but you can have a tuple. Okay, so if I run the first one, it gives me an error saying that list is unhashable. But if I run the second one, then that's a well-defined set. Okay. For initializing a set, I actually want to bring you back to the previous data types that we had. So if you want to define an empty list, you can do it using these empty square brackets. Or if you have an empty parentheses, then you actually have defined an empty tuple, which I'm not really sure where you can use it really. So for list, I can understand you have an empty list and you can keep appending numbers, but for tuple, it's not very useful. But for a set, you cannot use empty curly braces or curly brackets. And the reason is that this curly brackets is reserved for an empty dictionary. Okay, so if you want to define an empty set, just use the set keyword and then empty parentheses will give you an empty set. Okay. So let's say actually I want to define an empty set here. So this is how my set looks like. And then when you keep adding elements, you'll see that you have actually a set that contains some elements of your choice. But you shouldn't confuse this with a dictionary. We're going to see dictionary next. So when you use empty curly brackets, then it will define a dictionary for you, not a set. Okay. You also have the option to use the dictionary constructor using the dict keyword. We'll learn about constructors next week when we talk about object-oriented programming, but let's keep it as is for now and get to some built-in functions for sets. All right, so we had an example, similar example for lists last week, but now I have a set here which contains some strings. So here's how the set looks like. And now I'm going to add a new data point to that. So I'm going to use fruits.add and then the new data. It looks pretty much the same way append works. And what it does is that it will include this to the set in place, right? Because sets are mutable. Now you can actually add or remove elements. And you can actually do that in place. Okay. Okay. So now let's say I want to remove an element from this set. You can use the remove syntax. You actually can add more items. So let's say I have another set. So this is my original set, and this is my new set. Now I'm going to show you some of those operations that we learned on the slides. So let's say I'm going to get the union of two sets. So here's the syntax. fruits dot union, and here's the new set we define. And this will give you a new set. Okay, so this is not an in-place operation. So it gives you a new set, and I'll place it or assign it to this new variable. Okay, so your original one sets are not changed, but you get a new one, and you see that because we have this element orange, it exists in both sets. We only have one of them in the union one, right? Because sets do not allow duplicates. The other syntax for union is using the bar between the two. So both of these work. And for intersection, you change the union to intersection, or you use the AND operator. Okay, so this will give you the intersection of the two sets. If you actually want to do this in place, for example, you have a set and you want to add a few elements from another set to your set, something like extend does, now you have update. So dot update will update your original set with another set. Okay, now this is an in-place operation. It will change your original set. The other method is difference. So I'm gonna get the difference of two sets using dot difference, which gives you the union minus the intersection. Sorry, it gives you the elements which are in all fruits and are not in these common fruits. Okay, so it will remove that the orange, which was actually in the intersection. So if you try to remove an element which does not exist in your set, then you will get an error that this element is not a key in your set. So there's a key error, right? So whenever you see key error and this name of the key, it means that that key does not exist in your set. But if you want to actually, if you don't want to get any error so that your code will not crash, you can use discard instead of remove. So if you use discard for an element which exists in my set, it will remove that for us. But if I do it with an element which doesn't exist, nothing happens, and there's no error as well. Okay? And if you want to clear out your set, you can just use dot clear as we had for lists, and you'll get an empty set. All right, so we're at the end of sets. So I think we have enough time to go over these problems, I guess, at least using the Python built-in functions. So I'm gonna let you think about this for a few seconds, and then I show you the answers. In the meantime, I'm also gonna go over the questions and see if there are anything non-addressed. So let me make sure. Okay, so I'm gonna give you a couple minutes on this one. So the question is, given an integer, so let's actually go back here. Given an integer array nums, return true if any value appears at least twice in the array, and return false if every element is distinct. Okay, so here we have a set of numbers. I mean, it's a list, and then we have two number of ones, so they're not unique. We will return true, but here all the elements are unique, so we will return false. And in the third example, we also have non-unique elements, and we will return true. So I have also the question here. I'll give you a few seconds. Think about it, how you can actually solve this problem using whatever we learned today. And in the meantime, I'm going over the questions. Subra, do you have a question? I see your hand is raised.
Yes. So I'm trying to know like from where I can download these files to run in parallel. Like in the last class, I used to you shared the link and I downloaded it and I too ran it in my local parallelly. So I just want to know like where to download this flat files. If I have to run this parallelly in my system.
So you have the files downloaded now?
Uh, in the last class, you gave me a link, but I don't know about this class. Like it's
So
like
in
for
this
this
class,
class,
I also shared the link multiple times. You didn't get the link?
John late. I didn't get the link actually. Mhm.
So let me share it again. So can you see the link on the chat?
Yeah, now I'm seeing. Yep.
Okay, so just click on that and then download the file, and you can just open it up in Jupyter Notebook or Google Colab.
Yeah, sure. Yeah, I got this.
Okay,
Yeah,
let me
thank
know
you.
if there are any issues.
Yeah, sure.
Yeah. Uh, can use set here, start inserting values in the set. So I mean, so I see there's a question, I mean, or a comment that another approach here can be used dictionaries, but maybe set is better. So for now, let's stick to what we know so far. So yeah, you can also solve these problems, probably all of those problems with the dictionary when you can solve them with sets, but let's not worry about that for now. Um, okay. So I see there's a question that how are sets saved internally? So if you mean how they're stored in memory, if that's your question, it's pretty much the same as every other data type that we have. And it is a mutable object. So it will be saved by reference. Oh, actually, you're mentioning that since they cannot be indexed, so there's no we cannot find a pattern really. So you may see that you cannot really say any get any conclusion on the pattern that you get from how the elements are stored in a set. You can actually, when you see, you can get examples. So let's say I have a set 1 and then some string ABC and then 2 3, and then when you run it you'll see that it will change the order. So and then sometimes you'll see some weird things. I don't exactly remember, but uh, yeah, something like that. Then it will shuffle things around. So there is some definitely there's some ways to store these elements under the hood, but we shouldn't be really making any conclusions on the indexing and the order. Okay, so let's get back to this question. So there are two solutions for this. I want to ask for some volunteer to go over one, and then I'll show you the other one. So anyone wants to go over their solution? Uh, Vijita, please go ahead.
So I was thinking we could just take the length of the original list and then make it a set, and the set will remove the duplicates and do a length again. If it does not, if the new length is less than the original, then there was a duplicate, and or one of the values was at least repeated twice, and
Yeah,
that.
yeah, that's a great idea. And do you want to help me write it very quickly?
So we'll create a new variable to store length maybe.
Like n?
Yeah, n is equal to len of nums.
Uh,
And then the next line would be we could just do create a set or we typecast this into or convert it into a set.
Okay, like this.
Yes.
So let's call it nums set.
Yeah. And then dual length of it in a new variable. We could just do a comparison right away. If n is greater than len of num set, then we return true.
I think here we should return false.
Oh, false. Okay. Yes.
Yeah.
Yes.
So if that was not the case, we'll return true, right?
So the original length is greater than the. Hold on. The original length is greater than the new length. That means it was there were some duplicates, and we're returning duplicates. Then okay.
Right. So here it says if there's no duplicate. Oh, actually, I think you're right. I think this should be a true. Right. Sorry about that. So this should be a true. This should be a false. Is this correct now?
I thought so initially. I got confused when you. So we when there's more than, yeah, I think that length is, if the original length is greater, that means we found duplicates, and so we should return true.
Exactly. Yeah. So when n is greater than the length of this set, it means we have found duplicates. So when you find duplicates, you have to return true, which is what we're doing here. Otherwise, we return a false.
Mm-hmm.
Yeah. Perfect. So I think it should work. Let's try it out. Yeah. So it's true whenever we have a duplicate, and it's false when we don't. Yeah. Perfect. Thank you.
Thank you.
All right. So before I go, so we have two solutions here. So this was the first solution. We are using set, different properties to actually remove the duplicates, right? So we know sets do not allow duplicates. So when we typecast a list as a set, it will automatically remove the duplicates for us. So now if the length of the original list is greater than the length of the typecast set, then we're going to return true. Otherwise, we're going to return false. Okay, so that's what the question was asking. Now, actually, I want to also write this into in a single line. Actually, we can also do that. So I'm going to return the length of nums not equal length of set of nums. Okay, so this is giving us what this code will give us. Why? The reason is, first of all, I'm getting the length of nums and the length of the set of nums, right? So if these two lengths are not equal, then this statement will give us true, which is what we get right here if there's a duplicate. If there's no duplicate, the length of nums and length of set of nums are equal, which will give us a false here. Okay, so we can actually write these few lines into one. I also want to show you another way to do this, which is, one of the use cases of sets as well. This is an important solution, the second one. And that is to use a set for checking availability or checking existence. So I'm gonna define a new set. Let's call it check set, and it's gonna be an empty set. Now I'm gonna go through all the elements one by one, and if I see that element in the set, it means that I have a duplicate, and then I'm gonna return true. If I don't see it, I'm gonna keep adding new values, right? So for num in nums, so I'm gonna go one by one. If I can see the num in that check set, right, it means that I found a duplicate. So I'm gonna return true. If I don't find it, I'm going to add that value because it's already not in my check set. So I'm going to add that to my check set. Okay. So if I get out of this for loop without finding any duplicates, it means I have no duplicates. So I'm going to return false. Okay. So what I'm doing here is I'm using a set to check the existence of these values in a set. If it doesn't exist, then I'm going to add it. Now, the question is, why don't we use a list here? Why do we use a set? You can definitely use a list here as well. And here you can, so the syntax will not change here if you use a list. The syntax would now become an append. So if I can write it here. So I can write check, let's call it set again, list. And then here we would have check set dot append, right? And that's pretty much it. So we could use a list. But I mean, the syntax looks pretty similar, but the concept is very different, because when you do this check for a list, from a complexity viewpoint, this is a linear search. But when you check the existence of this number in a set, it's using a hashing mechanism to check the existence, which is a constant type. So it's much faster and much more efficient to use a set for this line of your code compared to a list. Okay, so that's why this is very important. This is a very important example and a very important concept. And this is the same for dictionaries too, which we're going to see next. Okay, so I'm gonna skip the next problem as a homework, but without, before going to the break, I want to make sure there are no more questions. I see there's a hand raised. Abhinav, you have a question?
Yes. From a asymptotic, complexity standpoint, wouldn't solution 2 still be a better solution than 1? Because in 1 you are completing you're transforming the entire nums into num set, whereas in the second one you don't need to,
Yes.
From a not maybe from an asymptotic complexity standpoint, because the worst case scenario would still be ON in both the cases, but if you normalize it a little bit, then it would be a better one.
So that's definitely right. I mean, exactly correct. So in the first solution, you are actually having this typecast from list to set, which is a linear operation throughout the whole list. So you don't care about the current element really. You care about the whole list and typecast it as a set. So the second solution is also linear, but it stops as soon as it finds the duplicate. So in some sense, it is more efficient. Yeah. So usually, as a rule of thumb, usually when you have a for loop in your solution and you do some operation as you move forward in your loop, that is more efficient than doing some operation entirely on that object and then go through the next step. So that's usually a more efficient way, but not always. So that was kind of a rule of thumb, but that doesn't always hold. Okay, thanks, Abhinav. Do you have any other questions or?
No, I'm good. Thank you very much. Thank you.
Perfect. Thank you. So I see there's another hand raised. Surab?
Yeah. So what is the memory usage compared to the first and the second? Like, since we're not really, we just typecasting, shouldn't the first one be with less memory compared to the second one?
Not really, right? So because when you typecast as a set, you are occupying memory needed for all the elements in your list, right? An additional, additional to what you had originally. But here you have an empty set, and you keep adding the elements one by one. I mean, so overall, if you think about it for a large scale asymptotically, they are the same, but in the second case, you are actually adding as you go. So it's going to be more efficient memory wise, I would say. Yeah.
All right. So, but for both, would the memory be again O of n?
Yes. For both
Yes.
is O of
Yeah.
n. Yeah, that's true.
Right. Okay.
Yeah. Cool. I see a couple questions in Q&A. So do sort first and then do comparison. So actually, that's a good point. So there are more solutions to this problem. So one is to sort the list and then check the adjacent items. If they are equal, then that's it. But then sorting is, from a time complexity viewpoint, is n log n. So you may not need that if you can do it in a linear way. So you may not need sorting, but that's definitely one approach. And the other question is, find duplicate in a set. Is this one line code correct? Return false. So I'm not sure if I'm answering the right question, but I think your question is, does this return the right thing? And let me go over this once again. So we are getting length of the original list and the length of the set version, right? So if there's any duplicate, then the set version is gonna give us fewer items. So then if there are any duplicates, then these two lengths are not equal. And if they are not equal, then this inequality operation, comparison operator, gives us a true, which is what the question is asking. If there are any duplicates, we get a true. If the length are equal, which means there are no duplicates, then it will give us a false, which is again what the question is asking for. So I think so it was a candid question. Sets always unique, so return false anyways. That's not the case. If there are no duplicates, then these two lengths will be the same. Yeah. So Milin, I'm not sure if I'm answering the question correctly. If you want, you can raise your hand and we can discuss it further. Hopefully, I answered your question. But yeah, great. Yeah, please go ahead.
Yeah, it was just a candid thing. We're talking about the list, but I just changed the question to set. So to find duplicate set, you can never have duplicate in the set. So the answer is always false. So just one line code. I just changed the question from the
right?
Find duplicate in the set.
Yeah, that's right.
Never have duplicate.
Exactly. Sets never allow duplicates, and this is what we are using here on line 8, right? So we are answering this question in one single line. So is this what you're also referring to?
Yeah, we are looking at the list here, duplicates in the list. But if the question was find duplicates in a set, the answer would be just one line.
So yeah, so that's I understand what you're saying, but you can never actually, the question can never put curly braces here for these things, because that's wrong. If you see a set and then you put similar objects, if you run the code, then automatically those duplicates will be gone. So basically, the question cannot give you a set with duplicate elements, right? But you can use the sets, the concept or the set functionalities to remove these duplicates. Okay.
Got it.
Yeah, cool. All right. So let's go back here. So I'll give you the second one as an exercise to make sure we're going to be on time. And you have the solutions both on the slides, and I also put the solutions on the notebook. So we had a review on lists and strings, and we also covered tuples and sets. We have one more data structure to go, which is dictionaries. And after that, we are going to see some tools. So we're going to see Python modules and functional programming. So let's take 10 minutes break and then come back to continue with the next topics. All right, so I'm going to be back in 10 minutes. All right, welcome back. So we're going to continue now with the next two topics, dictionaries, modules, and functional programming. All right, so now let's get to the last data structure in Python that we're going to learn. And combined with the previous ones, lists, strings, tuples, and sets, they're the most important ones. There are actually more data structures that kind of enable you in different for different use cases, but they're a bit more advanced. You're going to learn some of them in the data structure and algorithms course if you take. But these are the main ones. If I want to rank them, I would say lists and dictionaries are the most important ones. Strings are always, the first choice for textual data, and tuples and sets. I see them less in a day-to-day work, but you have to actually, identify a data structure when you see it. Basically, I use tuple unpacking all the time without even noticing, right? So you need to understand these differences. But I would say, especially for interviews, lists and dictionaries are the most important ones, and also strings. Okay, so let's actually go over the dictionaries. Or you may also hear hash tables or hash maps replaced for dictionaries as well, but they're all pointing to the same thing. So dictionaries in Python are ordered and mutable collection of key value pairs. So first of all, they're ordered in a very particular sense. So as of Python version 3.7, right, so dictionaries are said to be ordered, and the way we define order for dictionaries is a bit different from what we define it for lists and tuples and also strings. So in those cases, we have an index. So we provide the index, and starting from 0, we have index 0, 1, 2, all the way to the end, corresponding to the length of the object. But in dictionaries, by order, we mean the order that the items are inserted into the dictionary. So the item which is inserted last into the dictionary will be the first to be popped or removed from the dictionary. So in that sense, dictionaries are ordered. And that is actually recent. So after a specific version of Python, this happened. And then they're mutable. So you can change dictionaries after you create them. But most importantly, it's their structure. So they have a structure of key value pairs where for each key in the dictionary, you have a corresponding value. Okay. So this is the main difference between the dictionaries and sets. So one difference is the being ordered. So sets are not ordered, but dictionaries are. And the other thing is that sets only have keys, but dictionaries have keys and values. Okay. So the way to define dictionaries, you can either use curly braces like sets, but now you have key value pairs, not just keys. So that's the main difference. And if you want to create an empty dictionary, you can also do that using the dictionary keyword or the dictionary constructor. So similar to sets, the keys of a dictionary has to be immutable and unique. So dictionaries also do not allow duplicate keys. And the keys have to be immutable. But the values of those keys can be of any type. Okay, so this is very important. So you cannot have anything as keys. For example, we know that lists and sets are mutable objects, right? You cannot have them as a dictionary key, but you can have them as the values corresponding to some other keys in a dictionary. Okay. Okay, so some basic operations. If you want to access values of a dictionary, just write the name of the dictionary and then the key that you want to get its value, right? So you write the name and then the key inside the square brackets, and it will return the value of that key in the dictionary. So keep in mind that this is the key of the dictionary. It's not the index. You cannot find any value in a dictionary with an index. Okay, this is similar to sets. If you want to add or modify values in a dictionary, again, the dictionary name, the key, and then assign the new value to that key. And if you want to remove keys, key and value pairs, you can use .pop. And then it will return the value of that key. Okay. And then there are some methods to get a list of keys, the list of values, and the list of both from a dictionary, which we are going to see on the notebook. Some advantages and comparison with other collections. So dictionaries provide fast access to values based on keys. This is the similar mechanism as sets, the underlying finding of the values in dictionaries, values corresponding to the keys in the dictionary, is using a hashing mechanism, which is similar to sets. And when you want to find, check existence of those keys and find their values, it would become a very fast process. Okay, so that is one of the use cases of dictionaries if you want to check the values corresponding to those keys. And then they allow for easy and efficient mapping of keys to values. So there will be many cases where you actually have a representative of some group of items that you have, and you want to get quick access to those values based on that representation that you get. So that representative in a dictionary would be your key, and then whatever under that representative, whatever goes will be the value corresponding to that key. So it's a good way to actually get a lookup of those values in an efficient way. Or if you want to store and retrieve a particular configuration. So for example, one of the ways to store big data sets is to convert them into JSON files. And JSON files are basically text files converted into a JSON file, which can be read in any programming language. Those are lightweight files because they're simply characters. They turn all the CSV files or Parquet files, all those big data sets, into simple characters, which is much easier to store. It's gonna basically occupy less storage in your database, and it's much more efficient to work with. And it is language agnostic, so you can actually read them in any language, or you can use them in any code. So in Python, if you load them or serialize them into Python code, you'll see that it becomes a Python dictionary, because that's how JSON files work. There are keys and values, and it will become a Python dictionary, and you have all these functions that we learned today, a bit later on the notebook, with those files, and then you can deserialize them back to a JSON format. So JSON, we're going to learn at the end of next class, next week. And then one of the other use cases of dictionaries is to count the number of times an element occurs in a list, which actually you probably have seen or will see in many interview questions. And this is so common, and people get into different cases which they need such functionality that there's actually a library in Python named counter for that. So that's another use case of dictionaries. Now let's get back to our notebook and see a few examples. So first, like always, how to define a dictionary. So here I'm defining a dictionary for countries and their capital cities, right? So I have a dictionary named capital city, and I have these curly brackets, and inside that, so far everything looks like as a set, but from here I have a different structure. So I have keys and their corresponding values. So in this case, my keys are strings. That's fine because string is immutable. And the value can be of any type, but in this case, I also have a string, which is also fine. And I have a colon between the two. So I have key, colon, value. So this is my first item in the dictionary, first key value pair. And then after this comma, I have another pair and then another pair. Okay. So I have 3 of those pairs. And then for each of those keys, I have a corresponding value. So if I print it, you see that it will be lined up. And here's my list of countries and their corresponding capital cities. Now, let's say I'm going to check the capital city of, let's say, Italy, that I have it right here. So I write the name of the dictionary. And then inside the square brackets, I have the key, which is right here. And when I run it, I'll get the corresponding value. Okay. Now, let's say I want to get the same for Spain, which is a key I don't have in my dictionary, right? So if I run this one, again, I will get the key error. So if you remember, we had the key error for sets as well, if you wanted to check something which didn't exist in a set. So this is the same scenario here. We don't have Spain in our dictionary, so we'll get this key error. Now, we have a method for dictionaries when you don't have values or you don't have that key in a dictionary, you can actually get a default value for that. Okay, so we have the name of the dictionary .get, and the get gets 2 parameters. The first one is the key you want to check its value, and if the key value pair doesn't exist in your dictionary, here's the default value you will see instead. Okay, so this is what you will get. Now, if I want to add a new key value pair, so I can add it like this. So this is my new key in my dictionary, my new key, and then the value I want to assign to that key. And then when I run this, you'll see that the dictionary is now updated with Japan and Tokyo at the end, right? So in this sense, the fact that this new key value pair is added at the end, we say that a dictionary is ordered. Okay. Okay, so let's move on, and then you'll see how this ordering matters when we want to remove elements. So let's see another example. So we had this example from before, a person and their identity. So now we are going to turn it into a dictionary. So we have name, then the value would be their name, age, and city. So this is the dictionary. Now, I'm going to get a list of the keys, right? So let's say I only want to see what are the keys in this dictionary. So we have name of the dictionary .keys and nothing in the parentheses, which gives us a list of all the keys in the dictionary. And actually, it's a dictionary keys type because it's part of this class, and the class of dictionaries is defined in a particular way, and some of the stuff is actually basically enhanced, or there are differences with other objects in Python to make it more efficient for that particular data type. So if you need to work with Python lists, you can typecast this as a Python list. So we'll see that right here. But before that, we can also get a list of values. Here's all the values in our dictionary, if you want to isolate those values in one single list. And you can get all the items as a list of tuples, right? So you can get a list of tuples where you have keys and values as the elements in your tuple. Okay, so you can do that with items. Now, if you want to convert all those to lists, then you can typecast them as list, right? So the advantage here is now you have a list at your hand that you can actually use all the methods that we learned for Python lists to basically make any modification or any changes you need. But the downside is now if you make a change to this dictionary, now you'll see the update here, but not on the new list that you have created. So you have to do this typecasting again. Okay. All right. So the next one is removing values. So to remove values from a dictionary, you have a few ways. One is pop. So you can pop a key from the dictionary and get the value, right? So the thing about pop is it will return the value of that key. So if I pop age, it will return 25, which is the value corresponding to that key. And then this is the updated dictionary, which doesn't have the age, right? So we have another way to remove an item, which is pop item. But pop item doesn't get any parameters, and it only pops out the last key value pair added, right? So if you look at this dictionary, because of the ordering, this pair, city and New York, will be the last pair added. So if you do pop item, it will return that key value pair, and then it will remove that from the dictionary. Okay, and you see that here the value in the previous example only provides the value of this key, but here when you do pop item, it returns the item, which is a tuple, key value tuple. Okay, and then the last thing is the delete option, but the difference is delete will not return any value. So if you remove this key from the dictionary, you cannot return anything using delete, but it will delete the key value pair from the dictionary. Okay. All right. So iteration and existence. So let's say we have a new dictionary with digits for both keys and values, and this is going to give us the squares of the values. So the key is a number and the value is the squared of that number, right? Now, let's say I want to iterate through this dictionary and I want to get the keys and values one by one. So here's the syntax, similar to what we had before, with a little bit of difference. When you write for this variable name in the name of the dictionary, you're going to get by default the keys of the dictionary. Okay, so just writing the name of the dictionary here will pass us through all the keys of the dictionary. So I'm going to print out the key, and then I'm going to get their corresponding value here. Okay, so here's a pass through the dictionary keys, and you can actually make that explicit for the readability of your code to make it easier to understand by just putting .keys, but it's optional, right? So these two lines of for loops give us the same thing. They're equivalent. But if you want to loop through the values, you can explicitly write dot values here, and then your iteration will be only through the values. And if you want to iterate through a collection of items, like tuples, then you can put a dot item here to get those key values as pairs in a tuple. Okay. All right. So I'm going to give you an exercise. I'm going to give you a few seconds to think about it, and then I will reveal the answer. And actually, I am revealing the answer right now. But start thinking about this, and we go through the answer together. So let me run this for you. So this is our dictionary that we had before. And these are the keys and these are the values, right? My question for you is, go over all these lines, and each of these lines is going to give you a true or false. And then we have this arithmetic expression here, which I want to know what is the final answer. And the hint here is that in Python, if you have true and false, and you have an arithmetic operation for true and false, inherently what happens is an implicit typecasting where a true becomes 1 and false becomes 0. So keep that in mind, and you can put in the chat that what do you think is the right answer to this exercise, and then I will basically uncover the answer, and then I'll go over that. All right, so I see a few answers in the chat, and I believe most of them are correct, but let me first show you the answer. The right answer to this is 2. Let's see why. So the first one is checking 1 in squares. So squares, when we say squares, it search through the keys. So it's basically looking into this one. So this is true because 1 is in squares. So basically we have result is the first one is true, right? And the true is equivalent to 1, right? So 2 not in squares. 2 not in squares is also true because 2 is not in the keys. So this gives us another one. 49 in squares is false because 49 is not here. So it's going to give us a 0, right? So for D, it says 49 in square keys. It's not in the square keys. Again, it's going to give us 0. And then the last one, square values. 49 in square values is true because it's right here, right? In values, it is in values, but not in keys. So this one is a 1, right? Now, what is the answer to this arithmetic, arithmetic operation here? So we know that the first priority goes to the parentheses, which gives us a 2. And then then the next priority is with power. So 2 to the power of 0 gives us a 1, and 1 plus 1 will give us a 2, right? So that's why the final answer to this one is a 2. Okay, so a few more exercises. So I'm going to let you think about it while I think there are questions. I'm going to go over the questions in the meantime. So the first exercise is, we have a dictionary here. I want you to provide your answer in the chat in the form of ABC in one line. That what are these prints, right? So these are, we have 3 prints here. So just put what we're going to see in the output in the one single line. So that's one question. And the second one, you don't need to provide any answers. Just look at these cells and just think about what's happening here. So we are defining an empty dictionary, and then we're going to add some key value pairs. So think about how it looks like and what's going to happen after we do this. So yeah, so think about this, and then I will reveal the answers. So in the meantime, Subra, I see your hand is raised. Do you have any questions?
Yes. Like, so, what is the difference between int squares and int squares dot keys? Both are seems to be same,
Yes.
right?
Yeah. So basically, when you think about iteration and checking existence, they provide the same thing, which is the list of keys. But they're not the same thing, right? So squares give you the dictionary, and square.keys gives you the keys of the dictionary. But when you think about iteration, then in both cases, you will iterate through the keys, right? So yeah, so in iteration and checking existence, they're equivalent, and they only check the list of keys.
So when it will be different, like so both are same now in the iteration, but when it differs actually, like how it differs, they're not the same. Like how it differs.
They're not the same entity, right? Exactly. So they're not the same object because the name of the dictionary refers to the dictionary, right? So if you try to print it, it will print a dictionary for you. But the keys to the dictionary is different, right? So it's just a list of the keys of that dictionary. So the objects are two different objects, but for iteration, it gives you the same list.
Okay. So say for C49.
So Subra, I don't have your voice. It cuts off. If you can try again, or put your question in the chat. I want to make sure I understand your question clearly. Can you repeat that again?
Oh, is it audible? Yeah.
You are audible, but your voice cuts off. I'm not sure. Is it me or?
Okay, let me try now.
It's good now. Actually, it's perfect.
It's perfect.
Yeah.
Okay, thank you. So what I'm asking is like, say C equal to 49 in squares. It is not it is not checking the complete dictionary, right? The complete dictionary object, if in the complete dictionary object, it is there in the values. Actually, 49 is there in the values. But C equal to 49 in squares, it's just checking the key, right?
Exactly. Exactly.
Mhm.
Yes,
Okay.
that's exactly correct.
Okay. So again, 49 in squares dot keys is also doing the same thing, right? Like kind of
Yes.
only in the iteration it is same. That's what you're trying to say.
Exactly.
Okay.
Yeah. So that's
Gotcha.
right. Yeah. So this is
Yeah.
the nature of these two is different. So the objects, the type is different. This is a dictionary type, and this is the dictionary key type. But when you check
Gotcha.
for existence or an iteration, then both will search through the keys.
Okay. Gotcha. The operation is same. Okay.
Yes.
Yeah. Thanks.
Yeah. All right. Okay, so I see a few answers in the chat for these two exercises. So let me give you a few more seconds for those who haven't got the chance, and then I will go through the answers. All right, so let's go over the first one. So for this dictionary, the right answer here is this one. So it's a 9, it's an exclamation mark, and then we'll get a key error. So let's see why. So the first one, actually here we are checking the value for a given key, right? So the key is 3, and in our dictionary, you see that we have the key here, right? And the value will be 9. So that's what we get when we, in return. So this is the value for that key. Now, we have a key here 2, but there's no 2 in the set of keys. This get method will give us this value provided as the second argument when the key doesn't exist, right? So if the key exists, it will give you the value. But if it doesn't, it will provide this default value, which is right here. So the last one, because the 2, as we mentioned previously, is not a key of this dictionary, then you will run into a key error. So the main reason of this question is for you to understand that in a dictionary, you cannot actually access elements using the index. So you cannot basically say, all right, so this is 0, this is 1, this is 2, and the value of this second one is 81. So this is not how it works. Okay, so you have to provide the key to get access to its value. So the next exercise is assessing your knowledge about what type of keys and values we can have. So we now understand that we can only have immutable objects for keys, and values can be of any type. So in this first example, we have a tuple as a key, and the value assigned is 15. This is perfectly fine because a tuple is immutable, and the value is also integer, but could be of any type. So you may ask, why do we need to provide the tuple as the key? Sometimes you may need the key to contain a collection of items. So in this case, I have 3 numbers, and then the sum of those numbers is provided as the value, right? So this is one example. But yeah, usually when you see a dictionary, most of the cases, the keys are not a tuple. They're mainly strings or integers, but we need to know what are the possibilities, right? So this is one of them. So the second case, I'm adding the same pair, but now I'm changing the key into a string, right? So this is another way to do that. In this case, I have a string as my key, and a string is immutable. That's fine too. Now, the next one, I'm actually showing you that you can have different types as your key and value pairs. So here my key is 3, and then the value is a Boolean, right? And that's also fine. In the next 2 examples, I'm trying to add a key value pair where the key is mutable. So we know a list is a mutable object. It can be changed later. So that's it. We get this type error, which says we have an unhashable type list. And the last one is the same because the set is unhashable or it's mutable. We cannot have it as a key to the dictionary. So main reason of this exercise for you to know that we can only have immutable objects for dictionary keys. And these are some of those examples. So never try to use a list or a set or another dictionary as the keys of your dictionary. Okay. All right. So that was it for dictionaries. So we are now done with the list of data structures we wanted to cover in these classes. So before I move on to the next topic, which is how to import modules in Python, is there any question on dictionaries or whatever we've learned so far for the other data types? All right. So if there are no questions, let's continue. And I think we're doing good on time today. I think we should have enough time for another example by the end of the class, another lead code example, and then also enough time for Q&A at the end too. So Python modules. So what are modules? They are Python files which contain functions, classes, variables. So basically whatever we've learned so far, you can actually put them on this file. You can think of the file as a script. It's a Python script. You write all the code in one place, and then you save that file. And later in another code, you can import that and use it in your other file. Okay. So we have built-in modules, which are actually, which comes as part of any Python installation. No matter how you install it, there are some built-in modules which comes with your in your IDE or whatever you're using your Python to code. So some of them are listed here, like math module, random, date time, operating system, etc. There are lots of these modules for different use cases. We're going to see some examples of them. But you can create your own module, right? So you can write a code in a Python file and then save that file with .py extension. And then in that file, you can write functions, you can write define variables, any sort of logic procedure. If you want to write a class, you'll learn how to write a class in Python next week. You can put all that on your module. And then you can import the module in another file using this syntax, import module name, right? So same thing, if you want to import built-in modules, just write import and then the module name. And then if you want to use a function from that module, write the module name dot the function name. And then if there are any input required, you will put that in the parentheses. So let's actually get to the notebook. This is pretty much it for modules, both built-in and user-defined. Let's go back to the notebook, and then I'm going to show you some examples and how to define your own module. So the first example is math. So this is a module in Python for some basic operations, mathematical operations. You know, a lot of calculus stuff and simple algebra stuff you should be able to find in math module. But if you're looking for more like linear algebra and in scientific computing, then you're going to learn about NumPy in the last week. And there's also another package called SciPy, which is not covered in these classes, but it's also another scientific computing tool, which is a bit more advanced. So you write to import that in your code so that your code identifies all the functions and variables inside math. You write import, which is a keyword in Python, and then the name of your module. So import math. Then I'm going to show you a few examples now from the functions in math. So for example, math.sqrt for square root. And then you provide the number to find the square root of that. Okay. So you write the name of the module. There's a dot, like what we had for lists and other data structures that we learned. And then the name of the function. Okay. So another function is factorial, which finds the multiplication of numbers from 1 to the given number. So you can use math.factorial to get the factorial of a given number. Okay. There are also variables defined in this math module. For example, pi gives you the pi number. So math.pi is going to give you this number. So we have another function in Python, which is round. So round is a built-in function, not part of the math. It's just a part of general built-in functions in Python. So you have round of this object, and you want to round it by 2 decimals. And this is how we can do that. You also have trigonometric functions like sine, cosine, and other ones. So math.sine of this given value gives you a very small number because we know that sine of pi is 0. So this is almost equal to 0, some precision points that you don't see exactly 0. Or if you want to get the ceiling of a number, for example, you can use or a floor, ceiling or floor of a number. You can get it using math.ceil for ceiling and math.floor. Okay, so this will give you those. But these are just a few examples. Feel free to take a look at the documentation of the math module, and you'll see a lot more. The other module I wanted to show you as an example is the random module for random number generation in Python. So you import it first, and then you can use it to generate random things. So for example, for random integers, I'm going to generate random integers from 1 to 10. So actually, let's do a 5 here. Instead of 1 to 10, let's do 5 to see more numbers. So each time I run it, you'll see that you'll get a integer in this range. So the difference here is you see integers from both ends. So now it is not that this one is inclusive and this one is exclusive. That's not the case for random integer generation. So you're going to get a range of values, including 1, 2, 3, 4, and including 5. So that's one thing that may be a little bit confusing, but it doesn't really matter, because each time you want to use these functions, my recommendation to you is that try them out a few times very quickly and make sure you understand what's happening there. But you'll see some of these differences between functions in Python. So each time you run it, you'll see a different integer generated. Now I want to actually use list comprehension to get 5 different integers from this range, and this is how I'm doing it. So you see that I'm putting as variable name some underscore. The reason is I don't need it. I just want this to run 5 times. So sometimes you'll see that people put meaningless or an underscore instead of the variable name because they don't really need the variable name, and they want to show that in their implementation that this is something that we don't need. We just want this to happen 5 times. You have other functions too. So if you want, for example, to get numbers from 0 to 1, you can use random.random. If you want to get, choose from a set of given numbers, you can do that. So here's a random choice with replacement of 4 integers. I'm doing this 5 times and I get these numbers. If I run it again, you'll see a different set. Okay, and then the chance of picking these numbers is evenly distributed, but you have more options to change that settings. Feel free to take a look at the documentation, and there are lots of more things you can do. So the other syntax that you may need to know is from import. So sometimes you don't need that many functions in your code. So math comes with a ton of functions, or random comes with a ton of functions, and you may not need all of that in your code. Usually for these libraries is okay to import everything from an efficiency and memory usage viewpoint. But if it gets, if the functions that you're importing are intense or in memory intense, for example, if you're importing some machine learning package, then you don't really need to import everything from that. You just import whatever you need to make your implementation more efficient. Then you only import those particular functions. So I'm from this module, I'm importing only these functions, okay? Because those are the only things I need in my code. So now in my code, I don't need to put math.sqrt. Actually, if you do this, you'll get an error because now your code doesn't recognize math. It only recognizes these functions, right? So you just write the name of those functions directly. Okay. Same thing for random. So from random, I'm going to import randint or random integer generator, and then I can directly use that function in my code. All right. Now I'm going to show you how to define your own module. So actually, I have defined a module named Math Calculator. So I actually put this on the same Google Drive location as the other ones. If I want to also give you the link to that. Custom module. So I put the link in the chat for you if you want to check it out. But this is how it looks like. So I defined this module, which is a Python script. So I have this math calculator for the name, and then .py extension, right? And I have these 2 variables. I have this dictionary, and I have 2 functions. Very random, just bringing things from everywhere. to show you that you can have multiple different objects on the same file. Okay. Now I want to use this module that I've defined in my code. So I place it in the same location on my device as this notebook, so that my notebook can basically recognize that. But you can also put it in other parts of your device, or you can actually read it from the cloud, right? So to read a module from somewhere else on your device, there are a set of instructions. I've not put it here, but maybe I can actually put it here somewhere. But there's just a syntax that you need to add to actually make sure you can read those from other parts of your other directories in your system. But if you're reading these from some cloud platform, then you should follow the instructions for that particular platform. So if it's Google cloud platform, GCP, or it's AWS, if you're reading it from Azure databases, then you have to follow those instructions to see how you can get access. So basically, you can do this in your Google. If you have some file on your Google Drive, then you can do that directly in your Google Drive. There's a syntax for that. Then you can read from your drive directly. Now, I'm going to import that module in my code. And there's a new syntax here, as, which I'm going to import this library with a particular name. So why I want to do that? The reason is I don't want to write this long name every time I want to call any variable or function from this module. So I'm going to change the name when I'm going to use it in my code. So import this module as this thing. So this name is kind of a representation of the module name. So I run this, and now my code only understands what MC is, right? So if I want to call pi, so you know that I have this pi right here, written here, right? So mc.pi gives me this thing, right? Or also one other thing is that after you call this module, your custom defined module, then now you have a copy of all these variables inside your code. So you can also change the values. For example, if I print mc.e, then it's going to give me 2.71, but you can change your local version of that e and change the value to get the updated value here. Okay. So this is a little bit, I would say, could be a little bit controversial, because you may say, what if I don't want to make any changes to the existing module? I just want to use it. So we will learn about protected variables under encapsulation for dictionaries next week. For classes next week. So we will see how, if we want to restrict access to variables, how we can do that as part of our object-oriented programming variable definition. So for now, what I can say is Python gives a lot of flexibility for developers, and some of these things are intentional, and some of them are not, based on how the things are designed in Python to make it more flexible and easier to work with. So yeah, you may find it a bit different with other programming languages. Anyway, so moving on, so mc.pi, mc.person, and the key that you want to get its value, these are all now some stuff that you can do, because now this is a dictionary coming from your module. And it works like a dictionary in your code, because now everything inside this module is recognized in your code. Or you can call the function. So find square was a function we defined here, which gives you the square of a number. So if I run this, it will give the square of this number. And then I can also import that function, as you saw earlier, from this module. I'm going to import find square root, this function, or I can just get it from mc.square. Both are fine. Okay, so a very quick intro on modules and how to define your own module. So there is more to that for sure. So if you want to learn more details, or if you want to actually learn more about other built-in modules in Python, feel free to take a look at documentations and you'll see more. Okay, so I'm gonna now switch over to the next topic, but before that, let me see if there are any questions. So I see there are a couple of questions in Q&A. Also, there's a hand raised. So Vijita, you want to go ahead?
Yeah, so the as keyword, that can also be used for standard modules?
Sorry, so what can be used for standard modules?
The as keyword, like if you want to import as, it is only for the...
Oh, yeah. So that's right. So for example, one thing which is very common that you'll see on the last week of this class is, for example, if you want to import NumPy, which is a Python library, right? Then you can, people usually import it as NP, okay? Or import matplotlib.pyplot. So this is very long name, right? So usually it takes a lot of time for you each time you want to use it. So usually people, import that as PLT. And we also learned about pandas in the last week, which is usually imported as PD. Yeah, it's very common.
And so when we do that, when we did the user-defined ones, you mentioned that we could change the local variables in their values. That would also be applicable here. Are there any restrictions to that? Like, for example, some of the variables that are, or they're more like constants and you cannot change even in your local copy. Are there rules like those also?
So actually, no, there are no restrictions. You can make them restricted based on some, definitions, which we're going to see next week. But for now, if you don't add any particular syntax, it is allowed, right? So you can make any changes to those variable names.
Yeah. And one last question is, so any file that we create as a .py can be imported as a module in another file.
Yes.
Or another... Okay.
Yes, you can do that. So actually, not only you can use your .py files in your local directory on your device, but you can also, so there is a set of instructions how you can upload it for other people's use and make it open source. So you can actually make it a pypi.file where people can use pip install and the name of your package, and they can actually get access to your package online.
Okay.
Yeah.
Okay, thank you.
Yeah, thanks for the questions. Any other questions? So I see there are a couple ones on the Q&A. So there's a question that why would some people import a module as something else? I think you also answered that, Jeffrey, but I think, yeah. So as you mentioned, because you don't want to write the name, especially if it's a pretty long name, you don't want to keep writing that. So that's the main thing, I believe. At least for me, that's the case. But yeah, so there are also conventions. I mean, what I mentioned here, these are now so common when you want to use these libraries that I don't even remember last time I actually saw numpy dot something. I've always seen np dot some function. So the other question is, if I change mc.e to some new value, this will change the local copy. And that's right. Or the actual model can have those changes as well. No, actually. So you cannot change that module unless you want to actually create this module and save it on the same directory. I believe what you can do in that case, you can overwrite that file. I don't remember the syntax how to do that, but if you simply change these values, you won't be able to change that original file. But for overriding it, I believe there should be some way to do it. I've never done that, and I need to double check the syntax for it. But usually it's not a good practice, because you don't want to, if you want to change some module, you probably go inside that module and make your changes. Usually you don't want to make any changes to that module, the original module from your local code. Okay, so let's go back here and cover the last topic for this section. Let me make sure I'm back on the slides view. Okay, cool. So now we're going to learn about functional programming. So I'm going to show you a few more keywords and functions that may help you later when you read a Python code. So what we are going to learn is how to write things more compact. So I get a lot of questions that why do we need to do it? So the answer is that, you know, it's mostly for the readability of your code. So you learn these things for two main reasons. First of all, is to make your own code more readable and more professionally written. Because, for example, when you, instead of writing multiple lines for a function or for some mapping, you are moving the focus of the reader of your code towards multiple lines, and they need to spend more time for those few lines. But when you have it as a single line, it's kind of a shared I would say a shared sentiment that this is not the main focus in my code. This is just one single line to define it, to have the syntax. And now let's get to the important part. So I would say that's the main thing. But the other reason that we need to understand these functions is, you know, when you read codes, especially, you know, codes, you know, I've seen lots of codes in machine learning and algorithms. I'm pretty sure people use it for other purposes too, but at least in machine learning and data science, people use these things a lot. And if you want to go through their code and you see a lambda keyword, you need to know what it means. So that's the other reason that we have these slides and we need to learn them. So what is a lambda function? So we use this lambda keyword instead of the def keyword to define a new function to create, and we call it a lambda function. So here's the syntax. So we write lambda and then the arguments or the input to the function. And then after the colon, we put the expression which we want the function to return, okay, or perform. So here's one example. So here's the lambda keyword. There's no input to this function because there's nothing after lambda. Then colon. Then we have this print. So this function is not returning anything, but it will print hello world, right? And then the name of the function, we name it greet, and this whole lambda function is assigned to that function name. Okay, so then later in the code, whenever you want to call this function, you can simply call its name. So this is called lambda function, and this is very helpful when you want to write a function in one single line, or in the case of functional programming, you can use lambda instead of defining a function separately. You can just define it integrated with your functional programming. So the first example we have for that is map, which is a function which gets two arguments. It gets a function and an iterable and applies that function to all the values in that iterable. Okay, so let's say you have a list or a tuple. You want to go through those elements, and each time you want to apply this function. Let's say this function finds the square root of an element, or it multiplies it by some value or some string operation. I don't know. It could be anything. So it applies that function to all those values in that iterable. Okay, so you can write this function you know, somewhere in your code. You can just define a function and then use the function name here, Or you can use lambda function to write your function right here and make it as a package, right? So the whole mapping thing has one single package. So I'm just showing you the syntax and how it works, but we're going to see a lot of examples shortly. So the next functional programming function that I want to show you is filter. Again, for filter, you have a function and you have an iterable. And this time, your function is designed in a way which returns a Boolean, a true or false, and then is applied to each member of this iterable. If it gives us a true, it will keep those values. If it is a false, then it will filter them out. Okay. And then the last one is reduce. So reduce is for aggregation. So it's basically used for operations that combine values together. For example, summation is sort of an aggregation. Finding the maximum of two elements is an aggregation. So it's basically checking a few elements and then reduce them to one single element. So that's why we call it reduce. So it gets a function, an iterable, and an optional initializer, and it goes through that iterable one by one and applies this function to reduce those elements based on the criteria this function gives. For example, if it's summation, then it will go through this list 2 by 2, and for the first two elements, it finds the sum and then replace those two with that sum. And same thing for other operations. And then if you have an initializer which is optional, it will start the summation or multiplication from that given initializer, right? Okay, so I think it will not make sense until we see some real examples. So let's actually get to the notebook and let me show you some examples here. Okay, so the first example is lambda function. So let me remind you how we define a function in Python first. So this is how we write a function in Python, right? So we have define keyword and then the name of the function. And you had these arguments. You could also provide type hinting and everything. And then you would return some value. So then if you want to call your function, then you can actually write the name of the function and then you provide the arguments and you will get the final return value. Okay. Now, if I want to write this as a lambda function, here's how we can write it. So we have lambda. So there's no def anymore. There's no return anymore. The name of the function goes first. And then we have lambda, and then the input or the parameters in the functions header. And then what we are going to return, which is a plus b right here. Okay. So we are defining this function in one single line. And then calling that function and using it in your code would be the same. Okay. Again, there's no performance difference between these two. It's just the fact that you can have a lambda function integrated within your code. So you don't need to have a few lines dedicated to this function in the code. Another example, so I have three functions here. So the first one is the regular way of defining a function. But in this case, we have no input and no returns. We're just printing hello world. Okay. So the second one is the equivalent of this function with a lambda function. So lambda, no input, and then print hello world, and the name we call it grid2. And the last example is a lambda function, which also gets an input name, and when it wants to print, it prints hello plus that name. Okay, so not necessarily hello world, but hello plus the name that we assign. So we're going to call those three functions, and here's what we get. So the first two functions we have the same output in the display. And for the third one, we actually get this new world concatenated to hello. So we can have input written here and then use that input in our final expression. Okay. Okay. So the next example would be map. So map, as we mentioned earlier, is to basically apply a function on the elements on the iterable one by one and get a new list, right? So let's say we have this list and we define this function in the regular way. So this function gets a number and returns the square of that number. So if you want to use map, here's how we use it. So map of this function square, and then the list of numbers that we have. Here's the iterable. And you need to make sure that you typecast it as some data type that we learned already. So in this case, I typecast it as a list. If you don't do that, then you'll get some weird numbering. So let me show you what you get if you don't provide it. So here's what we get, right? So it shows you some memory location for the object of this map object, which is stored. But when you typecast it as a list, then you will get the list of numbers which have undergone this function. Okay, so let me put this below that. But you can also typecast as different types too. So you can have it as a tuple. And if I want to show you how it looks, this is what we get. Or you can have it as a set too. So let's have it as a set. Then, so in this case, you see that the duplicates are removed, right? So we have no duplicates, and also the ordering has changed because we don't have any ordering for sets. So yeah, so let's get it as a list. Okay, now you can do this with the lambda function too. So we don't, if you know how to write the lambda function, then you don't need to write additional lines of code to write this function. So here we have map, and then we have lambda number, which is our input, and the return value is number squared. And then here's the list of numbers, right? So this is our map defined here, and it will give us the same result. Okay. Okay, so the next example is filter. So let's say we have a list of scores, and we have a function here to filter out those scores based on pass and fail. So if they're above 75, let's say they're passed, and they're below 75, they're failed. So we're only going to keep the numbers which are above 75. So in filter, our function needs to return a Boolean. So otherwise, if it returns a value, then it will either interpret it as a Boolean, or you will get some error in some form. So the filter score is filter of this given function applied on this list of scores. Okay. So here's a filtered list based on all the numbers which are greater than 75. Okay. If you want to do this in one line, you can write filter, and then your function would be lambda of some input, and then your return value is whether that input is greater than 75 or not. So this will give us a true if it's greater than 75, and it will return a false otherwise. And then the list of scores, right? And the last example before we get some exercises is reduce. So for reduce, you actually need to import it. So I'm gonna import it from functools. So this is a library in Python providing some functionality. We import it here, and then let's say I have this list of numbers, and I want to find the sum of all these numbers. Okay, so I want to get the sum. So that is something we can do with the sum function, right? So sum my iter, right? So these two are equivalent, and I get questions in the class that why do we even need to know about reduce? Why don't we use sum? So that's a valid question, and you usually use sum. You don't use reduce most of the time. But this is a concept that you probably face later. The concept of reduce is not designed for summing up numbers or multiplying numbers, but for larger scale. So for example, how we can separate computations into different clusters and then aggregate the results from those clusters and do distributed data parallelism to make the code running faster, using the most out of the GPU utilization and things like that, right? So this is a concept for a larger scale. But now that we are learning functional programming, I'm showing you how it's being done for simple purposes. Later, you may encounter this, and then now what's the purpose, right? So it's mainly for aggregation. So I use it like this. So reduce, and then here's the function I'm going to use. The function takes two numbers, and it returns the sum of those two numbers. And then here's my list of numbers I provide here. And this initializer is optional. If I don't put anything here, it starts summation from 0. But so let's see what happens. So if I don't put it here, I will get a 10, which is the summation of all these numbers, right? But if I started from some number, let's say 5, then it will start from 5 and then starts adding up these numbers to that 5, which gives us a 50. Okay, so this is how you can use reduce in your code. All right, so I see there are a few questions, but I also want to make sure we keep the flow. So I'm going to show you some exercises, but in the meantime, I'm going to take questions. So for each of the exercises, just think about it. Feel free to put your answers in the chat, and please don't use Q&A for these ones. Just put them in the chat. And then I will go over them one by one and show you what the answer is. So let me see if I can show you all of them in one shot. Yeah, so these are all the questions. So go over them one by one and see if you can get the answer. Otherwise, I'll go over them for you. All right, so I see there are a couple hands raised. Abhishek, please go ahead.
Hello.
Hi, Abhishek, I can hear you now.
Yes, so just a quick question. The difference between reduce and map is map would still return a list, but reduce returns a single value, right?
Yes, that's correct.
Okay.
Yep.
Okay.
Yeah, exactly. So that is the difference in the return value, but also the functionality is different, right? So the map, provides a mapping on all the elements, but reduce is for aggregation mainly.
Got it. Okay.
Yeah.
Thank you.
Yeah. Thanks for the question. So next one is Vijita. Please go ahead.
So I have a question about reduce, the last example that you showed. I had a little bit difficulty understanding when you said the lambda function, right? So if I had to write this if I didn't do a lambda and I just wrote a separate function, then that would take two parameters or two arguments and return the sum.
Yes.
Right.
So we can maybe write it. So let's say my function, right? And then you'll get x and y for your function. and then you will return x plus y. This is the function that you can.
So how is it reduce? So basically, reduce keeps on doing for all the arguments in the iteration, iteration that the iterable object that we're providing.
So what it does is basically, so if we want to do it step by step, it looks at the first two elements, and then it finds the sum and puts it as, now that becomes our first.
Okay, gotcha. Yeah. Okay, that makes sense. Okay. All right, now I understand. Okay, thank
you. All right, so let me see if there are any other questions here. I think the other ones is answered. So I see that there's a question that why defining a function using def is preferred over lambda for usable pieces of code. So it depends, right? So it's not always the case. So usually people use lambda functions in setups like this, right? Where you want to actually write your function on the spot. But if your function wanna be there and people see that function and they can use it, you can actually put it somewhere in the beginning of your module or your code, and that helps a bit for the readability of the code. But it depends, as I said, right? So it depends on the use case. If you can use a lambda function, and this is a function you're not going to use over and over, then maybe you can use a lambda function. Yeah, it's also a kind of a coding preference as well. So I see there's another question that, can you write a lambda function if your function has multiple lines of code? So not really. So if it's a complicated, it's a kind of a complex task that your function is trying to address with multiple lines of code, then basically that's not. I mean, either you have to reform it so that you can write it in one single line. For example, if you remember that lead code problem that could be solved in one single line. If you can do that, then yeah, you can convert it into the lambda function. But otherwise, lambda function is not designed for a huge function, really. Okay, so I think other questions are addressed already. So I'm trying to see if anything that was missed. So the question, one other question is lambda function anonymous by definition without a name? So the answer is yes, if you actually define it this way, right, within, integrated within your code. But you can also assign it a name, right? So we saw examples earlier that, you can assign it, to have a signature and actually use that name for that. Okay, cool. So I see there are some answers provided in the chat for these questions. Let me go over them. I'm going to give you more time, but let me go over the first couple ones. So the first one, so it's asking what is the output of this code. So here's the function. And when we run this print, it will give us 20 and 8. Okay. So why is that? So the reason here is that we have a lambda function, and then we also have this if and else condition, right? So we talked about ternary operators in the previous class. Now, if a is less than or equal b, we're going to get this expression, and otherwise we're going to get a multiplied by b. So in this case, we are given a and b, and a is actually greater than b. So we're going to have this as the operation. So 10 times 2 gives us a 20. But in the second case, 2 is less than or equal b, that's right. And then we get b minus a, which is 10 minus 2, which gives us an 8. Okay. All right. Now, for the second question, let me actually give you a little bit more time, and then I'll go over that. So because I don't see many answers in the chat, so I'm wondering if people need more time on that. So let's give you 1 more minute, and then I'll go over that. All right. So let me go over the answers here. So for the first one, we are going to get only the negative numbers, right? So we need to write a filter for this list so that it only gives us the numbers which are less than 0. Okay. So for that, I'm going to write a filter with a function. So I'm going to write a lambda function, which gets a number and then gives us all the instances which are less than 0. So that will be a true, and I'm provided this list of numbers, right? So it only gives us a true if that number is less than 0. So let me put a list, and this is what we get. Okay. All right. So for the next one, we want to get the length of each string, right? So we want to apply a function that maps the string to its length. So in this case, we need a map. So now what to put in the map? So the first one has to be a function that I'm going to write it as lambda, which gets some value. Let's say gets the string, my string. And then what it does is it will return the length of the string, right? So this is the function, and then I'm provided this list of strings, right? So this will give me, oops, I need to put a list here. It will give me 5, 3, 6, which are the lengths of these 3 objects. So one other way to solve this is basically, so because this function is trying to define the len function, right? So we already have a function which does that for us. So simply, instead of writing this lambda function, I just can simply put a len here and strings, right? So this would also work. Okay. Because the whole point of this first element is to write a function, but we already have that function in Python. So the next example is asking to write a code to keep even numbers. So this one is another example of filtering, right? So we are going to filter this original list to get a subset of these numbers, right? So I'm going to use filter. So let's put in a list already, filter. And then in this case, I'm going to write a lambda function, which gets the number as input and wants to check if, so it's even number. So we want it to, when divided by 2, we want it to become 0. So num modulo 2 is 0 or not. Okay. So if it's 0, then it's going to be filtered as true, otherwise false. Okay. So this is going to give us this list. So if it's actually looking for a tuple, we can change it to a tuple. It's fine. Okay, so if you wanted to only keep odd numbers, then you would switch this 0 to 1, right? And will give you odd numbers. And then the last one is an example for reduce, which wants to find the maximum number. Again, we know that we can simply do a max numbers to find this, but we want to see how we can do that with reduce, because finding the maximum is also one type of aggregation, right? So the result would be, first of all, we need to import reduce, and then we're going to use reduce, and then the function would be, if we have two values, then we're going to get A, the first one, if it is greater than the second parameter. Otherwise, we're going to get B. Okay. So this is the function I write to find the maximum. Or you can definitely get you can also write max of A and B, but the whole point here is that we want to avoid using max. So I'm gonna just write this again, and I'm gonna go over all the numbers in this list. Okay, and then this should give us the answer. Okay. Okay, so before I get to the questions, so let's actually skip the lead code problem. I see that we are actually getting a little bit behind the schedule. So let me skip that. If you have time at the end, we can cover that, but we have one more section of the class. So let me skip that. And before getting for another break, I'm gonna make sure there are no questions here. So I see there's a question that in map, if an input is list of tuples, will the tuples be unpacked and pass as arguments to the function? Yes, you can actually. So this is an iterable, and for this iterable, you can put anything, right? So any sequence of items, but it's not tuple unpacking, right? So it's iteration through elements in a tuple. So what you said, Manoj, is right, but it's not called tuple unpacking. You're just using a tuple as one example of an iterable. The other question is, I'm finding this lambda a bit too complex. Maybe with practice it will get better. And the answer is yes, for sure. This is, most of the things that try to make the code compact, like list and tuple comprehensions, or ternary operators, or the lambda functions and functional programming, these can be a little bit complicated because this is not the way we are used to code or we have seen the code. And some of them a bit particular to Python. So if you see more code and if you try them out on your own, you will get more comfortable with it. All right. Any other questions from any of these topics we've covered so far? Okay. So I don't see any other questions in the chat or Q&A. So in that case, let's skip the class activity and we're going to go for a second break. And then after that, we'll wrap up the topics by covering scope of variables. Okay, so I'll be back in 10 minutes. All right, welcome back. So this will be the last part of this class. We're going to cover scope of variables and what we mean by call by value and call by reference when we call functions. I think this would address some of the questions from earlier in this class and previous class. I think we had a question on what we mean by value and reference calling in functions. And this goes back to whether a function is mutable or immutable. So first, let's see what we mean by scope of variables. So the scope of variables is the area in the program where a variable is accessible. Okay, so we have two main scopes, local and global. There's also another scope named non-local, which goes between these two. So we will see an example of it in the notebook. But our main focus here on these two main scopes, which are local and global. So local variables, which we also call function level scope, are defined inside a function. they're only accessible within that function block. And when the function is called, they are created, and they are erased when the function ends. Then we have global variables, which we also call script level scope, which are defined in the main body of the program and outside of any function or block. And they're accessible through the entire program. So when you want to use them in a function, you don't need to pass them as an argument necessarily. But if you want to modify those values, you cannot do that inside a function unless you define them as global inside the function as well. So I have to use the global keyword for that. Okay. So in addition to these two, we also have non-local scope, which is used for nested functions. So if you have a function inside another function, then you can make the scope of the outer function non-local to the inner function. So this is similar to global versus local, but in a different layer. Okay. So now, what do we mean by calling by value and calling by reference? So calling by value is basically restricted to immutable objects and reference for mutable objects. So inside a function, when we want to pass on different objects, when we have an immutable object, like a string or a variable with integer value or a tuple, a copy of the value is passed to the function. Okay. So we don't, the function, the scope of the function does not have access to the reference to where this object is located in the memory. Okay, so it only gets a copy of the value, and when you make a change to that value, the original value of the object remains unchanged inside the function. Okay, so then when you get out of the function, and if you have made any changes to that value, the original parameter, which was passed as an input to the function, will not be changed. Okay, because that's an immutable object. But that's not the case for mutable objects. So when you pass on a mutable object, which is subject to change, then it's called by reference. A reference to the original object is passed to the function. So what that means is that in the scope of this function, when you call a mutable object in the function header as one of the inputs, for example, if you pass on a list or you pass on a dictionary or a set, and if you make any change to that variable inside the function, then you're actually passing that change to the actual reference of that object. So wherever in your code, that reference is going to change. So basically, you get inside this function, you change your variable, you get outside of the function, but the change is now permanent. So even if in the main body of the code, you'll see that the value has changed permanently. Okay? So that's the main difference between calling objects by value for immutable objects and by reference for mutable objects. Okay, and this is very important because sometimes you need to pass on some, for example, list in your function. You want to use that list. Probably inside the function, you want to append something to that function or remove some element. Or get a subset of, using slicing to get a subset or whatever change. And then if you don't know what's happening, right? So if you don't know that call is by reference, then you may expect no change when you get outside of the function, but that's not the case, and that could be very tricky actually. Okay, so let's see some examples of that. Okay, so scope of variables. The first example we have here is a simple one, just to show you how it works between local and global. So we have a function here. So the function, inside the function, we define a variable and then we print it. So that's it. Okay. Now in the main body of the code, we have a variable with the same name as the inner value of this function, but with a different value. And then we're going to print that. Okay. So when we run this cell, the first thing which will be executed is this line, because the function is not going to be executed until we call it. So we start from line 5, and then on line 6, the only value of x we got access to is this global variable with value 4, right? So that's what we're going to print. Then on line 7, the function is called, and inside the function, we overwrite that value with a new value, which is now our local variable. So from now on, inside this function, x is identified as 5, as an integer with value 5. So when we print it, inside this function, it will be identified as 5, but as soon as this function call is finished, right at this point, that value would be erased and we'll get back to its global value, which was 4. Okay. Okay, so let's see another example. So let me put both in one screen. So now here we have a value 4 assigned to variable y. And then we call this function. And inside this function, now we are assigning a 5 to variable z. And we are printing z plus y. So this is okay because z is a local variable and is identified from here. And y is a global variable which can be used inside a local scope. Okay. So you can use it inside the local scope, but you cannot change the value of y inside the local scope. So if you want to change, for example, you want to change the value and make it permanent, you have to use the keyword global. We have an example of this, so let me actually keep it as is for now. But here, y gets its value from here, which is 4. Okay? So we will get that print and then get out of that function. We will print y, which is our global variable. But z, if you want to try printing z outside of this function, you'll get an error because z is not defined in the global scope of your code. It's only defined in the local scope. And then when you're out of this function, this variable will be erased and there will be no copy of that in the global scope. Okay. So if you run this, you'll see that you'll get 9 from this print. You'll get a 4 from this print. And then for this print, we get an error saying that z is not defined. Okay. Okay. So now getting back to that global keyword, let's say I want to make a change in my function, which actually is like a change in the global scope, right? So whatever you have inside this function is a local scope. But let's say you want to make a permanent change, which will modify that variable globally. So here's where the code begins. You have a global variable. You have this string AB. You're going to print it. And then when you call this function, right off the bat, this variable s is defined as global. So now if you make any change to that, it will actually override the value of this global variable that we define on line 8. So we define it as global, we print it, it still has the same value because we haven't changed it. We switch the value to another string. Now that we print it, it will be printed the updated value, but now even after the function call is finished, it will stay there, right? So even after that, we see that the change is now permanent because what change you made here is a global change because of this global keyword. Okay. All right. So one more example. So we have 3 variables, S1, S2, S3. the code starts from here. S1 is assigned. It's a global variable. S2 is assigned here, another global variable. Now we call this function. Inside the function, we have a local variable, but all of those other two are also accessible inside this function. So we can print all of them in one place under F, and we get all the names. Okay. All right. So now let's see a couple examples for call by value and then call by reference. So let's say we have this function, modify value, and it's going to get an integer as input. It's going to add 1 to that integer, and then it's going to return the value. So note that on this line, what we are doing is actually this. It's x is x plus 1. So it's not changing x, it's overriding x, right? So it's similar to what we did for tuples and strings when we wanted to change them. So we couldn't change the original value because they're immutable. So you have to override it if you want to change it. But anyways, this variable is now changed, right? So this variable is now overwritten by a new value. So when you actually, so let's define this variable. It's going to be, the value is going to be 10. And then I'm going to call that function. And it's going to give me 11, right? So 11 would be 10 plus 1. And then after that, I'm going to see what happened to that original value. So the original value was 10. After the modification, the value remains 10. And the modified value is 11. So the function does its work, but the original value is not changed. Okay? So this is one example of calling by value. So this variable, this integer, is called by a copy of its value, and then whatever happens inside this function is based on that copied value. Okay. Now let's see another example of immutable objects. Let's see a string. So we have the function modify string, which gets this string from input, and it concatenates with another string, right? Again, it's overriding that string with another string, and it would return that modified one. So my original string is hello, and I'm going to see what it looks before and after the change. So before the change, after the change, the same thing. But the modified string from the function is what the function returns. Okay. So again, after all these operations, no change to the original input. Okay. Okay. So now let's see a couple examples from calling by reference. So now when we actually insert a list as input to this modify list function, and then we append some number to that, right? So let's append 4 to this list. So given that original list is 1, 2, 3, so this 4 would make it 4 elements, right? So I'm going to print the original list, and then after it undergoes this function, I'm gonna again print the original list. Now you can see the difference, right? So the original list was 1, 2, 3, and then after the function calls it and does these operations, the original list is also, it is changed. So it says modified, but it's basically I'm calling the same original list, right? So this shows that a reference is now inside this function. Whenever this list is called, it's actually pointing to its reference, and any changes inside this function, even if you're not returning anything, the original list is changing. Okay. And we have the same fact about dictionaries. So this function, modified dictionary, whatever dictionary you pass on, it's gonna add this key value pair, or if the key exists, it's gonna modify the value for that key. Okay. Now, if this is our original dictionary, to two key value pairs. Then I'm going to print it. After modification, I'm going to print it again. And you see that for key 2, the value has changed to the new value. Although I haven't returned any dictionary, or I was not intending really to change my original dictionary. But because dictionary is a mutable object, it's called by reference inside this function, and the original value corresponding to that key is now different. Okay, so hopefully it makes more sense what we mean by call by value and call by reference. Now I'm going to give you a few examples and activities so that you can try it on your own and see if it makes sense now. So let me remove the answers to those. Okay, so we have 3 exercises here, and I want you to actually look at it and think about it and put your answers in the chat, and then I will reveal the answer. And in the meantime, I want to make sure I address all the questions in the Q&A. I see there are a few questions. So this question is, what is the output for all these prints? So we have multiple prints. We have 7 of them. So I want you to think about it, and in the chat, put your answer in this format. Just put 7 characters. It will be 7 digits, one by one, lined up. Okay, so just put your answers in the chat while I'm going over the questions in the Q&A. So there's a question that if I don't define global s inside the function and just do s, just change the value of s, so that is fine. You can actually assign a new value to any variable inside your function, and it will not change the global variable's value scope. But one thing you cannot do is to use a variable inside the function both as global and local. So if you want to print the value of that function from the global value, then you change the value locally and print it again. So I think you will encounter an error, because a variable cannot be identified as both global and local in one function. So you have to make sure that it's either local or global. Okay, so there's another question here. If I assign to same variable, it will show difference. So I think the question is on calling by value for integers, and the question is, for the same example, if I assign to same variable, will it show a different value? The answer is yes. If it's immutable, it will show a different. So the result will be different if you still use an integer, but the original variable will not change. If you go from an integer to some other data type which is immutable, then you'll run into an error, because plus equal 1 is only reserved for integers. Then you have to go through that exercise again to see what type of data you have, etc. So the next question is, so please put your answers in the chat. I see there are a couple of them in Q&A. How are you running Jupyter Notebook on local host? So if you're on a Mac, you can open it. If you have that installed, right, you can just write your terminal and then write Jupyter Notebook, and then it will, when you click enter or return, it will open up Jupyter Notebook for you. So this is how I run it locally if you have Jupyter installed. So that's the thing. So the next question is, why is x equals x plus 1 creating a new address location for x? Both are integers. Can that new value just fit in that memory space? I understand if we change integer to string, it may need new location, but same type. So they are the same type, but they're the same value, right? It's true the variable name is the same, but the assignment in the memory is a different thing. So if you're interested in how the values are assigned, in memory, then you can take a look at. There should be documentations, but I'm not sure 100% how it works under the hood. But because you have a different value, even for an integer with the same variable name, but for different values, you'll get different assignments when storage. So okay, I see a lot of answers in the chat, and I think most of them are correct the way I see it. Yeah, I think the ones that are provided are all correct. So let's see what's the right answer here. So the right answer is 3 1s, 2 1 3 3. Okay, so let's see why. So first, we have a global variable a, which has the value 1. So we are going to skip all these functions because they're only going to be executed when called. So here we're going to print that value, which is 1, right? So we get a 1 from here. Then we go inside this function, and nothing happens there, no change of values. So we're going to print a again, another 1, so we get 2 1s. When we get out of this function, nothing has happened really. So when we print a, we get another 1, right? So we have 3 1s so far. Now inside G, we overwrite the value of a because it's a local variable. It's just a temporary local change. So we're going to print that value, and then after this call, it goes back to the original value. So we have a 2, but then after G, on this line 22 print, we go back to the value 1 because it's a global variable and nothing has changed globally inside G. Now, after that, inside H, the first thing that happens on line 14 is that we define a as global. So inside this function, a is defined as global, which means whatever change to a is now permanent. So a is global, its value is 3. When printed, it will give us a 3. And then after we get out of this function, because that change is global, a remains to be 3. Okay. All right. So the next question I have for you here is another, scope of variable question. So I'm going to basically comment this out, non-local. I'm going to show you how it works after this, but let's don't worry about it for now. So for this global variable and then local variable here, let me know what these 5 prints will give us in the output. So I'm going to give you a few seconds on this as well. All right, so I see a few more responses in the chat. Thank you all for participating in class activities. So let's see what is the right answer to this one. So we have 30, 40, 30, and then 20, 30. So let's see why. So it begins from line 3, where we actually assign this value to variable x. It's a global variable. And then the next line of execution is 23. The outer function call defines this local value 20 for y. And then here we call the inner function. So when we get to inner function, we make x global. So whatever change from now on will be permanent to x. So we have 30 for x, which is now a global variable inside this function, and y is 40, which is local to this inner function. So this change of value will not change the outer function value. So 30, 40 will be printed here, which are these two prints. Then when we get outside of this function, x is changed permanently because it was global, but y is changed only local to inner function. So it's not changed in the outer function. So when you print it, it becomes 30, 20, right? Because y goes back to its original value inside outer function. Now, when we get back here, because x is changed globally, it will now become, it is 30, right? So that 10 in the beginning basically is, doesn't matter, really. Okay, so now if I have this non-local back, what happens here is whatever inside this function, wherever you see y inside the function, it is not local anymore to the outer function, right? So it's when it says non-local y, it means if you go one step back, one step outside of this layer, which is this layer, this becomes like a global variable to that function only. It's not a global variable for the entire code, for the main body of the program, but it's just not local to inner function anymore. It's also recognized by one layer above that. Now, if I run this one, you see that 20 becomes 40 because any change to y will change that value of y one layer above the inner function. So that's how this non-local works. Okay. Okay, so the last question for you is this one. So I want you to look at this problem, think about it for a few seconds, and see what is the output of this code. We have a modifier here, so it's a function, and we are given some initial values. Then they undergo this function given those variables, and we want to see what this print gives us. What has changed with the original values of these variables? Okay, so think about this for a second. I see there is a question that on line 13, it changed from 30 to oh, I see. So the question is, if we change this line to x plus equals 20, what happens in the output? So I think this is the question. And the question is, you have some value from here, then whatever change to that will be reflected in the output. So let me actually, so global x, x becomes 30 now, right? So you see that we had 30, but this line also makes it 30. So from now on, x is 30. So if I'm actually running this, if you don't see any difference, it means that it hasn't changed. So the x also becomes 30, and nothing really happens in the output because the value remains 30. And it's a global parameter, so it will be a permanent change. Okay, so let's get back to this problem. Let me give you a few more seconds. This is our last exercise for the day. All right, so again, I see a few answers in the chat. I see that they're mostly correct. I see a couple issues here and there. But that's perfectly fine. Let me actually show you how the final answer looks like. So the final answer is 4 different prints, which gives us these 4 things, right? Now let's see why is it the case. So what the function does is it will So first of all, there's no type hinting. So if there was no hints that I put here in these comments, then we had to understand what these are based on the syntax inside the function. So it's always helpful to put some type hinting here, but I removed that on purpose. So the first thing, A is a list, and we know a list is mutable, so it would be a call by reference inside the function. When we append a number, that will be a permanent change to that list. Then we have an integer, which is a call by value inside this function. So any change to the original value will not change the original value. It will just be a copy of that. So the third one is a dictionary. We are actually assigning a value or this key value pair. If it's already there, we are updating the value, or if it's not there, we are creating this key value pair. And since it's mutable, it will be another call by reference. And then the last one is an immutable object because it's a string. And this is basically an overwriting, which will not change the value from reference. It's a copy of the value here because string is immutable. Now, if we start from here, the first value starting from -1, this change will be permanent, so it will give us -1 and 3, both elements in this list. So second one, starting from 0 plus 4 gives us a 4 inside the function, but because it's an immutable object, it will be returned as 0 when called the original value again, right? So basically, this function does not change the value permanently. So the third one will be a permanent change again. So the dictionary is empty, but after this function call, it would contain that key value pair. And then finally, this string concatenation will not change the original value because string is immutable. So in the output, we only get hey, and we don't get hey world. Okay. All right. Any questions on any of these exercises and any of the topics for today? Actually, before that, there's another class activity here, a lead code, which I'm going to provide the answers for you. And I encourage you to take a look. And if you have any questions, let me know on Thursday session. So before I open it to Q&A, this is the list of topics we covered in today's class. Sorry, I don't know what's happening. Yeah, I'm not sure why. Okay, so we covered, we had a review on lists and strings, and then the rest of the data structures, tuple sets, dictionaries. So we covered all that in the class. And then we continue with some tools in Python, including Python modules, how to define your own module and how to use the Python built-in modules. And then we covered functional programming, how to write a Lambda function and how to use it for map, filter, and reduce. And then at the end of the class, we covered the scope of variables and calling by value and call by reference. So we're going to continue this next week, but the format of the class will be a little bit different next week. We're going to begin with object-oriented programming, and that's going to be an extensive topic. So we only have about 2 hours for that topic, so we have to, include a lot of things in that time frame. So that's why that will be a big portion of the class. And then after that, we're going to continue this list. We're going to talk about custom sorting and reversing and JSON files and how to read and write files in Python. A few more topics before we go to Python for machine learning in the last week of this series. So yeah, thank you all for joining, and hopefully I see you all on the Thursday session for assignment review. So I'm going to stay here for a few more minutes if there are any questions. Otherwise, feel free to drop, and I will share the notebook with updated answers and everything. and I'll put it on the same Google Drive location that was accessible earlier. Right? Any other questions? So there's a question that can an integer pass by value? The answer is yes. I mean, it's not up to the values. It's just by definition. Integers will be passed by value in a function because an integer is immutable. So when you pass it to a function, when you pass a variable to a function which has an integer value, it will be passed by value. Okay, so basically a copy of that value will be passed to the function. So it's not that it can be passed by value, it always will be passed by value. Okay. So there's a question that what is a non-local scope? So actually we had this example here, right? Okay, here. So if you have a non-local variable, then it basically makes this variable identifiable inside this inner function. So it's kind of become a global one layer up. So this is maybe the best way to describe it. It's not global in the sense that now the main body of the code recognizes that, but one layer up, because this is a nested function, when you define it as non-local y, if you make any change inside this scope, that change would also be reflected in the immediately outer scope. Okay, so that's what we mean by non-local. So the question is, what is the order of the function running in the outer function and inner function where x is 10 and y is 40? What is the order of the function running? Yeah, so Fatma, maybe I'm just trying to understand the answer. So I think maybe I can go over this example for you again. So we have this 10 and we have this 20, right? If your question is about the status quo, this is what happens. We run this function, the outer function, and inside the outer function, y is 20, right? And then we call inner function. Now inside the inner function, x and y are defined to be 30 and 40, so that's what we print. But because x is global, that change is permanent. So when we get out of this inner function, now the value of x is changed, right? So from this inner function, now we jump into this print, which gives us 30 and 20 again, right? Because 20 inside the function is local, right? And then we get out of that outer function to print x again, which now, because this value was global, would be 30. Okay, so this 10, we defined x to be 10, but because as soon as we get into this inner function, we change the value globally, that's what not you see in the output. Hopefully that answers your question, but if not, please let me know and we can further discuss that. I see there's a question that on which folder are you going to put the file? So wherever you could access the previous files, I don't know where the Google Drive directory is actually. I just put it on up level and it puts it somewhere on the Google Drive. So wherever you could access those files, the updated file should be accessible right there. Okay, so you should be able to get all those files in one place. So there's a question that how does this change non-local? So when you have non-local, then this change out to y will also be changed in the outer function. So this 20 would now become 40. So when you print this y here, it's not 20 anymore, it will be 40. Okay, so this non-local will make this y non-local to inner function, and basically will be identifiable in the outer function too. And thank you, Jeffrey, for sharing the link. Any other questions? I don't see any questions in the chat and the Q&A. And okay. So if there are no more questions, then thank you everyone again, and have a nice rest of your day. I'll see you on Thursday for the assignment review session. Thank you all.